are more like so we went through that, went through the rolling budget. Now we went through all those cases and did what we could do that time. Now I want to continue with what I was supposed to finish, and that is the quantitative techniques in form of quantitative techniques, which of course affects also budgets. We need to go because a budget is a planning tool, and the best way to know something that is planned is mostly requires estimation. And since it requires estimation, then in this chapter here, they have also decided that students need to know the estimation tools or estimation issues that we go through. So anyway, before I go to the estimation, just let me mute somebody at the background. So before we move on to before we move on to quantitative techniques, zero-based budget, if you need kind of the details, I'll still make more details understand, but also there's the details in F5 which explains what a zero-based budget is. I find it, if you need the details, because I've only made some summaries on my slide, but it is, if you need the details, you could get there. The principle behind the zero-based budget is referred to as ZBB, is that the budget for each cost center should be made from scratch. So there's no formula. Every time they make new budgets. Of course, it is costly and it's time consuming, but it is, of course, has benefits because it is more, to the debt and more, questionable and eliminate exercise. So every item must be justified in order to be included in the next year's budget. So zero-based budget just doesn't take anything. It's not like the fixed budget where you wake up and they decide we continue with what we were doing last time. No, it requires you justify the components that you are using at that moment. And those components, you must justify them before they are a part of the budget. So you must justify its every item must be justified in its entirety in order to include in the next year's budget. So, in exam, it is important to apply the knowledge. Of course, they are said that most times they would ask you to just explain things in terms of that. So, you need to be, I've never seen where there is a calculation because, as I said, mostly it is from nothing. So something from nothing, it means there's no formula to apply. Yeah?
Sorry, sir.
It means you sit down, you discuss, you justify, and that's what it is. It is when it is included. So it starts from zero.
Hello.
Yes. Are you talking to me?
Yes. Can you help us and look on the question on April 2023, question 3?
Is it calculation or theory?
It is calculation.
No, there's no question on zero-based budget that is calculation. It will be the first time maybe where there is that. If it is in April, I think I'd have noticed it. But anyway, the one I've seen even in April, just if I check that, because maybe for your interest, but I think, let me check that because I didn't notice that there is a question which is asking somebody to calculate that. If it is in April, then I could easily have seen that because as it is, most times I've only seen question on theories where I've cut across any other cases relating to that. Probably, which question was?
Question 3.
I don't like opening this part here. Let me open with the other one. This one usually hangs and start to rotate. Let me open with Mozilla. I could open with Mozilla. That Adobe usually hangs a bit. So when I open it, you see now it is rotating without doing much. it's not really working effectively as I thought. Anyway, let me use this other one. I could use this one here, and then I cross-check which question is that you're talking about, because the other one is disappointing me. It is just hanging up. While I don't have, maybe my patience is not that good on that case. So if I use this, let me see which April question you're talking about. I think I seen it is within 1003. 1043, yeah, let's see, 103. Yeah, it is there. So let me check and see. The question number, you said question number what?
Question number 3.
Question number 3. I think question number 3 was asking critically evaluate the current STI budgetary and advise on how to implement zero-based. It's not calculation on zero-based. It's just there are two segments. There are two statements there. One is you analyze. You do your analysis of what is given. So it's not like it is the zero-based that is being calculated, because if you check that question properly, you notice that question is asking two things. It is asking this and then implementation of zero-based budget system would improve. Implementation of zero-based budget would improve university budgets performances. So here it is a advice, meaning you need to go and introduce what is zero-based budget and of course look at possibilities of how zero-based budget would improve whatever you have analyzed. So that's the case that you need to follow through to get to the point of what you need to have it done. So it isn't like it's calculation. Where the calculation will be, actually is not even anything you're calculating here, because you are simply checking performances. You are simply critically evaluating the current STI budgetary system, which you need to check the budgetary system that is existing from that period. I think STI is using another different budget, so they want you to advise on whether they could switch to zero-based budget from that. And even if you say the statement given, there is a budget, there is actual, there is variances already computed. So of course, all you need is to talk about the differences which are existing, which is the variances between those two, between the actual and what was planned. And then from there, you look at it in terms of what it could be or what it may really entail. So the calculation is not on zero-based budget. Zero-based budget, what was the only thing you needed to, you needed to find the weaknesses of the current budget or the current system they are using. Even if there is no weaknesses, you needed to explain how zero-based budget will improve. And zero-based budget, the best way to explain that is to understand zero-based budget, which is what we are trying to, first of all, get the idea and open for discussion and see how zero-based budget can be. So it isn't like it is a calculation as such, but before anybody answers this, you need to get the knowledge of what zero-based budget, how it works, how it operates, because here, as you check down here, they are asking you to advise on how the implementation of zero-based budget would be. So you're supposed to first of all give introduction of what is a zero-based budget, because they may not know what is a zero-based budget. Of course, they don't know. And then the next thing is you talk about the concept, how it is kind of works and how it is implemented, and then you come in and then you offer how it's supposed to be implemented from that. So the zero-based budget that was tested there is it's even when you look at it, it's most times the way zero-based budget is tested is, of course, to explain, to do that, and of course talk about it in terms of its benefit. Like in this case, we'll just talk about it. I think if you check even the suggested solutions, maybe I don't think there is anything which was calculated on the zero-based budget. The only thing that could have been done was the first part. This is the one I've underlined here, because here you needed to do some critical evaluation. And the evaluation is quite easy. They already given you a report. They already given you a report, which is of course relating to having the tuition fees. We have tuition fees which are there. So you needed to go in and uncover some things, because you can't also critically evaluate if you don't understand. You need to talk about, the variances, if they have increased, those issues. You need to talk about the school fees between Q1 and Q2, because you need to talk about everything else that is there. Because when they say critically evaluate, they haven't limited us to anything or pushed us to test only one component. It is open it is open. You can test either the comparative between the variances between Q1 and 2. You can test, of course, the fees between that, whether it's growth in between that. Those are things you need to test, and you advise on that. You can test the training fees. You check there is an actual they are doing this, and this is the day. This was the budget. Did the budget increase? And maybe you check into those issues and critically evaluate each component one by one. And because each component has like 6 columns, so you need to have a comparative that will be also on three bases, kind of. If not really, you need to talk about that and check those. So it was more about writing than even doing calculation or anything, because already the report is there. So that it's mostly like theoretical. All you need is to test all that. You check this, did it increase? Did it reduce? Did it what? Complement on those, the grant also they got what, all those, check the variances, check all those cases, and you go down, and each component has like 3 things, 6 columns, and you need to talk about the comparatives on 3 things: Q1 budget, Q2 budget, actual Q1, actual Q2, variance in that Q1 and variance of course in Q2. So those are the things you need to talk about, and it's already calculated. So you do some maybe growth issues, differences, all those things. Comparative analysis, it requires you check maybe growth, incrementals, blah blah, and stuff like that. But the ZBB part here did not require calculation, so it's not a calculative issue. Anyway, what I was trying to say is that before that, I was trying to say is that you need to check and see other issues which relates to this, and those are the ones I was trying to check. You need to check. You need to understand the concept properly of ZBB, and because ZBB is more theoretical, I'd wish not to take so much time on it. You can read. I think most of you can read this and get the point there. It is here. If you need a reference, it's explained in the F5. I want to go to the calculation quantitative part. And the good thing with reading and writing, it is reading and understanding, and you know how to conceptualize in your own ideas would make it better. But that question to be answered, you need to talk about implementing here. So the suggested solution, your suggested solution should be you first of all introduce what is ZBB, and then after that you kind of go down to its benefits, and then implementation. Implementation, there are 3 steps approach there. So you need to talk about the 3 approaches, and then talk about, of course, how it will improve those 3 approaches. You need to define, because you need to define the items or activities for which the cost should be budgeted. Those are the answers will be extracted from there. And spending decision, that should be planned. These are decision packages. Evaluate and rank packages in order of priority. Eliminate packages whose costs exceed their value. Allocate resources to decision packages according to ranking, and that's the cases. So the implementation should be discussed within that line, and you should even mention how do you do this. They say that ZBB is a questioning attitude. Does the activity need to be carried out? Number 2, what would be the consequences if the activity was to be carried out? Is the current level of provision sufficient? Are the alternative and cheaper ways. Are there alternatives and cheaper ways of achieving the same objective? And how much will the activity cost in terms of that? So is the expenditure worthy the benefits achieved? All those. So you need to talk about those for purpose of implementation and go through that. Now, I'll leave for you to digest that and go through during your free time, because as I said, BBB has nothing to calculate. Why? It starts from zero. Something from zero means it starts from no background of a formula. So you can't. The only way I'll expect ZBB to be tested is they set through a concept of a theory, and if they set calculation, they will set you to analyze and pick what should be budgeted or not. That is maybe if I was an examiner, that's how I would think of setting ZBB. Theoretically, because there's no formula, how will you set it? For rolling, we say it is changes with incremental, meaning there is a formula to factor in that. What is that changing factor? Or it changes with factors of variables changing and incremental, those ones. But also the flexible budget, we have also a formula of how it is flexing. When you go to ABB, it is also factored in on using the ABC. So all those have some background of arithmetic or formulation. But this one, there's no background. You start from zero. You come and question and do whatever it is upright. Now, anyway, I don't want to waste so much time on it. I wanted to go to quantitative. Actually, this day was to cover quantitative techniques, which are in the budgets, because the budget is supposed to be is a planning tool. And when you do budgeting, you have some estimation you use. Most of us plan. And when you plan, there is estimation you are using. When you wake up, you go to town, there is estimation you are using. You are using the estimation. That's the money you carry is based on estimation of what you want to, how you want to spend. So we all go through this process of estimation. So estimation is not a new thing, as I would say that. It's not a new thing. It's just maybe because we want to go through it differently, it looks like maybe new, but it isn't. So there is we have already gone through. There is the objective of this is to analyze fixed and variable elements from total cost data using HILO and regression method. On one occasion or two occasions, we have made HILO already. We did a question on break-even, there was HILO. We did a question on target costing, there was HILO. And mainly HILO was assisting us to split the total cost into variable and fixed. But it's not only HILO, we also have a model referred to as regression, which can assist you to also do that impact of that. Then explain the use of forecasting techniques, including time series. I saw there was a question asking the benefits of time series, simple average models, and the estimate on a judgment and experience, predicting the future, and all those predicting the future value from a provided time series analysis data using both additivity and proportional data. Estimate the learning effect and applying the learning curve to a budgetary problem, including calculation of steady state. Now, most of you have been through quantitative analysis. I think whether it is, I know you are exempted, but you are exempted because you covered it in campus. So it means I'm right by saying that you've been through that. So learning curve is the only thing which I think is new here. Learning effect could be what students get to new information, get to understand is a new thing they are getting to interact with here. So learning effect is what will be new here. But most of the other things you already encountered. Regression is covered in some circumstances in business mathematics, in campuses, you have covered through that. You have gone through how regression is calculated. Time series is also covered in quantitative methods, and all those are covered for that. So the only thing that is new here is learning effect. All those methods, while you are doing them, you are not just doing them. You are doing them, they are supposed to be used in estimation. And the tool of estimation here, or the planning tool that we are talking about here, is budget. And budget uses those techniques. So there is that. Some people use Excels and all those cases. to focus, and whatever case, spreadsheets and that is it. So this PDF, I like it because it summarizes this in a visual way. It has all that being summarized in a very visual way that it is from that case. So you'd get to know that. Let's catch up with this. There is a quantitative techniques, mostly as these are quantitative techniques in budgeting. There is when you want to, of course, do analyzing fixed and variable cost. We use high-low or regression. We talked about this in one time during different segments of different questions. We already met high-low, and we already used it in some questions here and there. There is also time series. Time series has 4 components, additive, and the 4 components you will also have to go through. There is what is called trend analysis. We have what is called the seasonal variances. We have what is called the residual variances. Not residual variances, sorry, random variances or random variations. And we have also what is called economic cyclical variations. So there is learning curve. We'll go through learning curve. There is 3 approaches you may use, but commonly we use a formula. The 3 approach involves tabulation. Another approach is formula. Another approach is graph. Graph, nobody would bother to do that based on the model of how questions are tested. They wouldn't really require you to extract a graph from that cases. Formula covers all, and it gives whatever you may need from that. So, but we'll just explain that. So there is learning curve using spreadsheets. Spreadsheets, I know most of you are in working, you are already know how to project and use budgets. You have Excels, you use Excels, you just factor in growth and you or changes, and you use that is spreadsheet. So we wouldn't want to go through that. But if it comes, you're already familiar with it. It's practically used in job areas where they use Excel from that, and that is the case. So that is the overview of what we intend to go through. Now, unless there's a question there, I want to strategically choose what to start with. I'm going to start with the learning curve because, as I said, time series, I know you already maybe have covered somewhere else. Regression may be covered somewhere else, and the high-lows on that case. So I prefer to choose what is because of time interest. If time beats me, I'll have at least done what is called learning curve. Regression more likely is just a formula. High-low already interacted with it one way or another. It doesn't change even when it's here. It's the same thing you already have idea about. And regression is just a bunch of formulas and you get what it is. Time series is a rare component that has ever been tested and very scarce. Maybe if they test one time, they just test theoretically. And then maybe in 2019, there's when they also, but it was already calculated and all that. So time series again is just also covered in between some levels you may have gone through. So strategically, I'm trying to start with learning curve. I'll try to go through learning curve first, and then I go back to the finished learning curve. And learning curve is shorter. The questions that are there are shorter actually, again. So I want to do the learning curve, and then I go to regressions, those analysis of fixed and whatever cost, fixed and variable cost, and then I finish with the time series if time gets me. I think from my experience, even most of you check across whether it is in SCCA, CPAK, or whatever. Time series is something which is not popular in that area as a forecasting as such. But it is a tool you need to know it is there. So I'll clear that as the last one. So let me go to learning curve, unless there's anybody who has an issue with that. If there's no issue, it's strategically how I've decided to choose that. So my intention is to cover learning curve. Based on time factor, always time gets me on the wrong side of things when I'm still trying to figure out, time is trying to figure out how to navigate through certain issue. Time cuts me out, and I wouldn't want it to cut me when I've not done learning curve, because learning curve is a new concept to majority of you, unless otherwise. So there is what is called learning curve. For the others, I think you can grasp them up. Now, learning curves is also referred to as learning theory. Most of you, all of us, not most of you, all of us, let's say all of us go through this process. Nobody is born knowing things. We learn. And learning is one thing which I say is perpetual. It will go like forever. If you are not learning, then you are doing very bad. You're not doing good. You're not really, somebody who is doing good to yourself. Learning is a process we go through every day, every night, and of our daily life. Even when you are hired, you didn't know the job properly. Your first days, you gamble here and there to struggle to know, the several things here, to what to press, what not to press. Maybe with a computer or maybe software, and that is how you learn gradually. But as time goes by, you become perfect, or you become better. Let me say better. Perfect is too much. Is a big word used. Perfect is not easy, but you become better. Let me use gradually. You become better. You are hired. You are told you need to repair computers, or you are told to, if you are hired and you have to make computers. The first day you may make one computer, not the first day. Let's say even 1 year is when you make one computer, or 6 months is when you can assemble and say, I've produced my computer. So that is the learning part. So the first instant always shows how far you have gone. Even when you started school, in the nursery, it has been a learning process up to where we are today. So learning is a process that keeps on going. So as a worker becomes more familiar with the production of new product, average time and average cost per unit will decline. And it's very true. Most of us, we have that much of experience when you are given a job, which could take a new person long time. You find you take very short time. So that shows you have been learning, and you can take it, you can do a short time. But your cost reduces, because while you do for a short time, there is another ground that they give you to continue doing, or they give you more tasks. And when they give you more tasks, or when you finish that, you find your labor averagely per certain unit is cheap, because of the experience you have has made you become more efficient. The more you learn, the more you become efficient with what you do. And that's why I say learning is better to be embraced every day. So learning curve is like that. So learning curve applies to situation where the workforce as a whole improves in efficiency with experience. And this is very practical in our world, or what we do. The more you learn, the more efficient you become. You can finish a task in very short minutes, or very short, or very few hours. So the learning effect describes the speeding up of a job with the repeated performances. So even me, I can't say, even me, when you're hired as a teacher, the first day, of course, you are trying also to navigate through and understand how to make, things, you achieve your objectives easier. And as you grow on, as you keep on growing, you realize, okay, I need to be doing this. Maybe I need to be doing this and this quickly to get to the point where I need to finish the strategic performance. And then the focus, make students cover whatever they're covering. So it is a learning kind of an issue. So the learning effect describes the speed up of a job with the repeating performance. As you repeat your job daily, remember, life becomes like that. Whatever we do is what we do repetitionally, and we become more efficient. Where does learning curve apply? High labor intensive. It is applied in the brand new or relative short product, and also process does not continue indefinitely, complex, and all those cases. So there are 3 approaches that we use. We use what is called tabular, we use graphical, and we use algebra. Algebra is a form of formula that we use. But from my perception, I would advise, you use algebra, which is a formula. A formula, you can call it a formula. Now, the application of learning curve, where do we use in business? We use it to determine the labor cost. I have I'll share the application in the Excel later, but we use it to determine the labor cost because it affects a lot. You see, we are talking about somebody, and that somebody contributes labor to the business, and so it assists in labor cost. Another issue, it assists in determining performance evaluation, because you know whether the person is learning or not, and that is the case, or how his learning is, or something like that. It assists in setting the standard. That's why somebody can tell you, why are you taking too long? This thing always takes 2 hours, and maybe you are taking 10 and 2 weeks. So there is that standard that has been set by prior people who have done the same job. So it assists us to set the standard. Learning also assists us to determine remuneration, how much will be paid. Learning assists us to determine the price of a product, how much the price of a product will be, because as labor is part of production cost, and even labor, sometimes the labor hours affects overheads in absorption scenario. So anyway, that's what learning curve does. So let's use what is called tabular approach. I want to use what is called tabular approach, and then I convert it to formula. And if you like it, we can go to graphical as it is. Because as I said, it's a short area. It will take more or less within 30 minutes will be done. So we'll have other time left for other things. So immediately, unless there is anybody who's still wondering what learning curve is, I've tried to explain. It's very practical. It's very practical with our life, with individuals, with human beings. Human beings have to learn in order to become perfect. And I guess that's why when somebody is elected as a manager or given a manager position, is because he has been in the learning chain and is able to be more efficient in that area. So anyway, there's a tabular approach. Now, commonly, there are some assumptions we use. I'll write the assumptions later on. But the assumptions are that they are similar as the weaknesses. We assume that because today you produced 1 computer, tomorrow you must produce 2 computers. No, we'll use 2 computers to see if you have learned, to get what is the average of 2 computers that you have done. So usually I call it doubling effect. The doubling effect. That's why you see here, it went from 1 to 2 is a doubling effect. It went to double to 4 to that. So whoever came up with this structure was applying what is called doubling effect, that we can only measure learning if not on 1 computer you did yesterday, if you come today and at least target to do 2 computers, if you are making computers, then we'll see how many hours did you take on the 2 computers, if you have learned anything or not. If there is learning, we'll use cost track from that. So there's an example here. As I said, it's very practical. We just need to go to the Excel and apply the practical element of it and check the question. So I had copied that in my Excel just prior to meeting you. I think I had done, is it this one? Yeah, it is this one here. So I have it here. I brought it here so that we can use it to see how it is. So in that question or that example, they have said they have a learning, or if you read it, that the first unit, and something I want to talk about it now that I can write here, requirements when you're solving a learning curve, how it works. The first hours, or the first cost. Let me start with hours. The first hours, the hours, let me start with the word hours. The hours spent, the hours on the first unit are very important, are required always. If not, cost on the first unit, cost per unit, cost per unit on the first unit is quite critical, because the first part, the learning is progressive, or it is tracked from that. So the cost on the first unit is very important on the first unit. That's why in any question they have to give you either hours spent on the first unit, or they have to give you cost spent on the first unit. That is very critical for that. And that's why here in this question they have given you that. Now, another issue is that there is some key assumptions. The key assumptions I've said we assume that there is the learning is through doubling effect. Learning is through doubling effect. Learning is through what you call doubling effect. Doubling effect. And again, the learning rate usually remain the same. Learning rate remain the same once determined. Learning rate remain the same once determined. What else? The cost per unit is not an issue here. It is all about how you are learning. Cost of labor, cost of labor. Cost of labor remains the same. It remains constant, or once it is known, it remains constant. That is the idea. And another issue is that learning curve is applied mostly on in units industry. Learning curve is applied is applied mostly in units. You know, and not service. It could be a weakness also. Anyway, that is it. There are some assumptions which are there. So we assume doubling effect. We'll see how it assists, and that is the case. So here, this is a question. The first unit is a learning question, which will lead us to understand the formula. After understanding the formula, we apply the question. After applying the question, we already finished, and that is what it is, nothing much. So the first unit of output of a new product requires 100 hours, full stop. An 80% learning curve applies. The product times would be as follows. So let's see, let's fill the table our own to understand. So the first unit, averagely, here there is a column. So I've developed some columns, which are usually tested in the question here. The first unit will requires 100 hours. That is the average time. If you check, that is the average time which we are talking about. Average time required per unit. Total time required per unit. And the incremental, the changes in between. So total time, of course, will be, because this is average, meaning per unit, you multiply with that. So what is the second? This is the first issue. What is incremental? Incremental is, of course, you know, we'll come to incremental later, but that's a total. Let me focus on this first. Incremental is the changes. We'll deal with that later. So what happens if you produce the second unit? Now, because there's a learning curve, it is believed that the learning curve is 80%. Remember, we have the learning curve rate. So the learning rate has been given. If you split that issue, learning rate is 80%. So it means every time you move to the next process, which is doubling, your average cost will reduce, or average, you know, hours will reduce by 80%. So here, despite the fact you'll produce this, it will be reduced by 80. That is what the learning reduces. You are learning, so you reduce the hours spent by 80. That is how by tabulation to be. Then if you multiply this by 2, you get, in total, you spend 160. So because it's doubling effect, next to double to 4. Next to double to 4. As it double to 4, next period, you are producing this, and it will be cut by, of course, 80%. So it will be 64. And this will mean this, multiply by that, you will have 256. And as it doubles, it goes there is that, which of course is that. And because it is 64, it is slashed. You are still learning. So you have to deal with that, and you get that. This will give you the total. That is the process of how learning curve was developed from its way we handle in the formula way. Okay, so that is it from that scenario. So this is what we'll have for that case. And I think we'll put it that way. Somebody's saying I put the work vertically. It is usually makes problem while printing. Okay, try to follow that. You know, so there is 8. This is 8. If you multiply, you get it equals to that, and it gives you that. So that's the case. We have our work there, or we have our work cut out for it. It could go on. It could go on. It could follow this pattern. It could go to, now this pattern it is following is pathetic. It could go like 16, all that. This would go on. But in sometimes learning curve is assumed to it doesn't go to zero. Let me say it that way. There's a point where the learning stops. There's a point where the learning stops as it is. I think I've already, somebody's asking me to elaborate on it. I've said, even if I give you a question, we do question. I'd give you 2 questions to see if you have learned. That is process of learning, is it? I give you 2 questions. If I give you 1 question and you do in 30 minutes, next time I'll give you 2 questions to see have you learned how to move. That is doubling effect. Similarly, it is applied in that issue. That's why it is what they used to, that's how the person who came up with this was using that. If today you produce, and I said this, today you came and you work for the tech company, you made 1 laptop. 1 laptop cost, took you 1 month. 1 laptop took you 1 month. So next month we'll tell you, make 2 laptops. We will not will tell you, we will want to know if you have learned. We'll pick how many months did you take to make 2 computers? Because on 1 computer, there is nothing to learn on. We'll want to see how many hours did you take now to make 2 computers? Because the first computer, we already know what you do, what you did. So the second computer is you take 1 plus the other one, and you get 2 computers, and you deal with that. So somebody used what is called doubling effect. It's an assumption which is taken in it. So as I've said here, we assume doubling effect for those who did that. So it's an assumption. So if you find there's weaknesses, just know it's also part of what it is. But it makes sense at the beginning, maybe gradually, as you go on, maybe it is not making maybe so much sense, but that's how it is. At the beginning, it makes so much sense to me, because if I give you a task to make a computer, next time if I want to know whether you have learned, I will see now how many, I will take the 2 computers you made. No, I'll take the first one and then benchmark it to the next 2 computers you make, and I get if you improved over the period of time. But learning curve stops. So don't think learning curve continues until you get a 0. No, there is nowhere you can say you worked 0 hours and you made computers. So there is, yes, it keeps on reducing, but there's a point where it stops. As you may notice, it keeps going down, but it stops. Even you at your job, you learn your job. There's a point where the learning now is not, you are not learning. You are just doing routine work. There's a time when you're not learning. You're just doing routine work. You go there, you fix your work, you go home. You are not learning anything. Or if there is any learning, it's on a very minimum scale. If there is any learning, it is what I could call, it's insignificantly what you are learning. And that's why some people usually sometimes would want to even leave the job and go to another job, because they see that they are not learning anything in that job. They have already known what the job is all about. Sometimes it becomes boring because you already know everything around here and there. So you are only there to fix what it is and go to your way. So learning stops. Learning stops at certain point, or learning gradually reduces. And that's what it is from that angle that I want to say. And that's why if you check like in the curve like this one, this is how it is when it's in the curve. There's a point where it gets to a saturation, and it starts very aggressively, but goes to a point where it is a straight line as a curve. I was trying to do that here, but I just did some small part of it. So if it continues, it will be like a straight line. I did up to 8 units, which is not bad. So if it continues, you'll find it is into it slants or goes like this and like that. So there is where a learning curve is not longer, you're no longer learning anything. The curve just go that way. But anyway, so unless there is anybody with a question, how we got total time, I have said we'll take what is here, which is this one, you multiply with the average. Average is of course per unit, and you get the total of that. If there's no question, we need to go to incremental. Incremental is the difference between previous and today. So here there is no previous, so it is 0. It is 100 minus 0 because the 0 was the previous. So you go on, incremental will be now the current, subtract that, that is incremental. And this will run subsequently like that, and those are incremental, meaning that this incremental, this incremental, this incremental, that is incremental. So incremental is a change from one point to another. Another name of incremental is simply to say change, which is here it changed from 0 to 100. So it is 100 which came in, and then from 100 to 160, 60 came in, from here to here, and that's it. So we call that incremental. Now, you don't need to worry. We have what is called formulas. You don't need to make a table like this unless you find it's necessary. But assuming a person make a table like this and ask me, what is my learning rate? What is my learning rate? It's quite easy. The learning rate would be, if somebody was asking me what is my learning rate, I would simply say my learning rate, learning rate is the percentage. I will take this, divide by where I was from, and I get to 80. And that will happen even at any given point. If you take the averages, which is the previous, the previous, divide by, take the current, divide by that, it usually gives you the learning rate. So if somebody give me a table like this and ask me to calculate the learning rate, I can easily just check what is transitioning here and get what it is. I can take the averages, like this is the average here today, divide by that, it gives me that. And I get what is my learning rate in percentages. So how to get the learning rate is that learning rate is the percentage. So a learning rate can also be calculated if it's not given. Learning rate can be calculated by using, it can use, of course, the current average. If I may say that, you take the current average, divide by previous average, current average time per unit, average time per unit, and then you divide by previous, the immediate previous, actually the immediate previous, the immediate previous averages. So that is the case, and that's how you may get that. I'll put that in its formula probably later on, but it's a quick way of just making sure. Now, we have formulas. We have formulas. I've shown you graphically, and I've told you nobody will ask graphically, but graphically you'd see this is how it may be for 8 units. If it continues, of course, it will stretch like that. So we have the graphical element, which is there, which is that. So I used 100, which is that. You could use any other figure. It depends, but whatever you want to use there. So I just decided to develop that. So graphically, it could be something which the learning starts aggressively. And here it starts to narrow down to reduce as it continues. I wish I could be able to extend down here, but it's enough. It's enough. Nobody will ask you for graphical issues. It's just last like that. Because in the question, in the format here, they have said it can be, you can use graphical as you plot. Also, the graphical can be used, which are here. You'd notice they say it goes simply like that, and that is the case. But the cumulative cost, there's a time when it is increasing, but then when you learn, you become cheaper labor. The more experienced you are, sometimes you have to be very careful. The more cheaper labor you will be also, sometimes, if you're not good in negotiating. You know that, because you'll be doing a task very quickly, and people think it was very easy. And they pay you per hour, while in reality, it took you more, the experience is what made you be there. So they pay, that does happen. I know it happens even to you at your job sector. Somebody pays you because he sees you can do the work quickly, and they feel like it costs you no time. But then the reality is, because of your experience, don't take experience for a joke, or experience doesn't come cheaply. So you have to be careful again. Sometimes, as you may see in the curve here, the labor becomes cheaper. The labor becomes cheaper as time gradually goes on. You are learning and you're producing more units at the same cost. Remember, the labor is the same. Salary doesn't change unless you can even fight to increase salary. You know that. Once you're hired, the negotiations power are always the time when you have option to talk and make the best bargain. Immediately you're in the job system, my friend, it becomes you have no option to negotiate. Do the work, do the work, do the work, do the work, and do the work, and do the work. So your labor could come cheaply with time as time goes by, because your experience or your labor cost is on another level, but the salary has never catched up with that experience. So that is the issue. Anyway, it's part of life, and that's why it is what it is. Anyway, we move out here to the Excel. Now, there are formulas. There are formulas which are given. Let me show the formula here. I don't want to type it. The formula is here. The algebra formula. We usually say y is equivalent. This is the formula. I've shown you the tabulation. The formula for learning curve is y is equals to a multiplied by x, which is units, and raised to the index, which we'll call it b, where b is a learning coefficient or learning index, is defined as log of the learning rate divided by log 2. The learning curve can also be used to solve all learning scenarios. So what is y there? Y is the average time, cumulative average time to produce a unit. What is x? X is the number of units, the cumulative number of units. What is a? Time taken for first unit. But I have to add something here. Sometimes it's not only time, sometimes it's also cost taken to produce the first unit. So it could be also cost per unit on the first unit. And that is the case that it is from that. So that's the case that it is from that case. You may have that. It could be also cost per unit. And that is what it is. Then there is learning index. A learning index is, of course, you take the logarithm or the log of the learning rate, and then you divide and get what it is. So that is what I could say about that. So there's a formula. So above all, there's a formula. Unfortunately, the formula is not given in exam. So you are still young. So you have to remember it as it is. There is a need for you to remember the formula whenever you meet such task or whenever you meet such area in exam. So that is the formula, but it's an easy formula. It's only, you know, this and this, and you get whatever it is from there, is it? So somebody told me to do vertically. I don't know vertically to what extent, but usually I like to put where I can see all things together. But so this is the formula. Okay, B has not come out clearly, but this is the explanation. I wanted to copy paste that so that I don't write all these. We don't have time for me typing all that. So what I need here is just to put the formula in my own way here. Now, this formula calculates average, but you can multiply the average to get totals. This formula calculates average. But how does the formula work? For example, if I have this table, I can simply calculate this table with the formula and I get it. I don't need to do tabulation and listing all the possible areas. I can simply deal with the formula. It's possible to use formula to calculate this column. That is what they are telling you. This column can be done using a formula. How? The cumulative section can be calculated. So while this one is on tabulation basis, this one here is on tabulation basis. Here, this is a tabulation. This is tabulation basis. You can also use the formula. You can also use the formula on that basis. So it's possible to use the formula. It's possible to use the formula. How? You can simply use the formula as it is, and that is what it is. So there is what you can do. Like if I want to use the formula here, because I just want to show the demo. So here it is y. Let me use the way where I can raise, because raising will require some skill a bit. Just to could use maybe inserting some slash here, so that I use that. So basically, if you check, if you may need to do that, so just a minute. Let me admit somebody here is saying I've not admitted him. Anyway, y is equals to a x and then raised to, I can use this to raise to b. That is how you get that. So that is what you do, and you get this column here. This column will be obtained, and that column can be calculated using that. That is to get what you call the the averages. How? Let's use the formula and see. We know X is the number of units, and A is the number of hours on the first unit, and B is the index. So how do you calculate the index? Those who have calculator will do that, but there is B. B is usually an index. Oh, B is an index. So how to calculate B? Usually we do it as an index. So B, I can calculate B as an index, and I can do that maybe just as quickly as I thought I could do that. So B is an index. B is an index. So the index is you take log. Okay, there is something which happened there. So you take log, and you divide, you take log as a dividing factor, log of 2. Log of 2, of course, to base 10. It is usually to base 10, so don't use another base. There are several other bases. So you take that and you use it to get what it will be from that case. So you use log 2. Now, on the other side, you take the learning rate and the divide. That is the log 2. In my perception, it came because of the doubling effect. So they use 2 as a constant in it. So this is how you get what we call B. B is equals to that. B is usually computed that way. So it's an index, and I think, as I've said, we compute it that way. So like in our scenario here, B will be, of course, if you were to calculate B in the context of what you have there, then you will get that B will be computed as 80%. You will have B as 80% and then divide by log 2%. So you have to know that you'll have it as 80%, or maybe let's say 0.8%, and then you divide by whatever it is. So those who have calculators can do that. You will take log. Log is part of calculator. So you take log, and of course you have 0.8, and then you get is equals to, I think it is only log. Okay, even base 10, it gives the same. So log to base 10 is equals to that. So that gives you the numerator. Then get log 2. So you have log 2, and that will give you what it is. Log 2. So you get log 2. So by the time you take that, you divide by these, you get it is equivalent to that. So you have all that, and you get, that is how B is calculated. That is how B is calculated. So you got that. This gave us the numerator. So in context of that, that is what we had. I forgot to put here the word log. Log of learning rate. Sorry, I think I only put learning rate. It is log of the learning rate. I should put that way. So that is correct. Then here it is log. Yeah. Of that 80, sorry, of that 80. So you take that, you divide, and you get, it gives you whatever case you may want to get from that. And that's what I wanted to say by that. So you divide, you get is equals to that. So this is the numerator, which means log 0.8 is equals to that figure that you got there. And log 2 is equals to that figure that you got there. By the time you divide the 2, it gives you that. So let's apply and see. So the first one is that what is A? So that is B. The question, another question will be, what is A? A is the number of units you use to produce the first unit, the number of hours or a cost. Like in this case, A is 100. So we have 100 which relate to that. So the rest, X is this one here. This will play the role of X, which is the number of units, which we'll have for that, right? So that is okay. So if you do that, you take, now I want to run the formula here. I'll take 100. I'll take 100 as 100 would be locked throughout, will be the same throughout. So multiply by multiply by, of course, x. X will be this to run down, and then raise to open the brackets, put this figure here, and you run like that, you get it 100. So hopefully everything is intact, including this should remain the same throughout once you find it. So this will remain the same. The other things will be variable inside. So if you do that, you get it runs through, and it gives you all possible averages. Although here it is giving that, maybe I'll check why, because I don't know if I did correctly here, but it is saying is that, and here 40 comes here. Let me check if it is that. Why is this one 44? This one, I think I'll check and see why it is. Is it doubling? No, it was not doubling. The doubling should have been 16 and 32. That's why. So it should be that way. So that is the case, and that's what we have, and that's how we calculate these if it is using a formula. That is how the formula is extracted from that data. Now, the formula can also be used to calculate total. Total, you will multiply, when you have average, if you buy a bread, 10,000, if you buy 10 breads, and if you buy 10 breads, and the money you spend is 10,000, I can take the average is simply the number of breads, the amount you spend divided by breads, which is 1,000. Similarly, if I know the bread is costing 1,000 and I have 10 breads, I can multiply. In short, this is the rate, which is per unit, is required per unit. So you can multiply and get totals because it is time per unit. So you can multiply and get total. So what I'm saying, when you multiply, we can call it T. The formula can also be used to get totals, but after you do the arithmetics and this, when you use the formula, it becomes 1 plus B. 1 plus B is what you are raising to. That is if you want to calculate the total, assuming the examiner, you are not able, you want to calculate the total quickly. In fact, the total is usually required, this formula, because the question sometimes asks you to calculate incremental. Incremental meaning for specific product within a certain interval. So you have to calculate it. So total is like this. But how does total come like that? Is simply when you take this data here, when you take that and you multiply, because I know most of you know, you know the mathematical issue here, background here. If you take this one is of course a franc per unit, or a dollar, if you're using dollar, whatever currency, the whole of this gives you per unit, whatever you get in this case here. Similarly, whatever you get on the outside is of course, if it is dollar, it is dollar per unit. So I've said you can multiply with the variable called X, which X represents the number of units. So this is the average. Average, just average. This is the average time per unit. So average time per unit can be multiplied and get total time per unit. So to get total time per unit, total time, not per unit, just total. Total is not per unit. You will take average. You will take average time per unit. Then you multiply with what? Number of units. Now, number of units here is represented by X. Number of units is represented by X here. So, so how do we agree with that? Let's check it out and see how it could be done. So in this case, when you multiply this factor here with X, this original factor here with X, you are getting the total. So that is why what I'm trying to talk about in many words. I'm trying to tell you that when you multiply whatever you're having here, it will give you total. So multiply this by X. So if you multiply by X, those you know there's X here. So X multiplied by XB will give you that. So there is X raised to the power of B and multiply by X raised to the power of 1, because that is it has a silent 1, and that's where the 1 comes in. When you multiply this component with X here, it gives you X to the power of 1. That's where plus 1 comes from. And this remains, of course, the same. X is the only thing which will multiply. And because we want to get total, I will not call it Y. I have to call it T to simplify that T is a total. So T, in that context, is equals to total time. So total time can be calculated like that. But the formula changes very minimal. So it is not expected to be a big deal. Where does it change? Only the power. You plus only 1 to factor in the multiplying factor of X. So how can we get the total? Now we have the formula. To get the totals, we'll get, of course, A, which is that which will remain relatively the same, multiplied by X, which will be this, which will change relative depending on different scenarios. Then after that, you were supposed to, of course, raise to the power of. Remember that bracket is in the power, raise to the power of this figure here, this one here, plus 1. And you close that and you get it equivalent to 100. Now, because this will remain the same throughout, let me close it in like that. So if you do that, it gives you the totals, and the totals are similar to that. You notice they are the same as that. This one is similar as that, is similar, 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 like that. So totals are calculated like that. And how do you calculate incremental? Incremental, you can calculate incremental without using a table. You can use totals. You can use total to calculate incremental. How? If I was to calculate, so this is what this comes to A. Let me put there, multiply by that. And then, of course, as in certain, it is T. T is equal to that. So by the time you do that, you find when you simplify it, it gives you what I have on top there, which is the 2x's. The 2x, there was this one, remember, it is in the power. You know, the problem is raising to the power issue. So these are powers. So when they come, they do each other, and then this is equals to that. Anyway, I'll do that probably later in details, maybe if you need to. But it's simply like that. It doesn't need so much. Nobody will ask you to derive. Anybody will ask you how to solve some questions, which is to apply. So in terms of that, we can get incremental. Incremental is equals to, if you want to get what we call incremental. For example, I want to calculate incremental. I will take T of subscript. Excuse me, just a minute. So if I want to calculate, let's say it is incremental using a formula, I can calculate incremental using a formula, and it's not also a big problem for that. But how do I calculate that? You can calculate incremental using, of course, whatever you are given, the totals. So the totals can calculate incremental. How? You could take like T for, like if I want T for maybe 2 units, I subtract also, this is if I want to get T for 1 unit, sorry, I want to get incremental. Let me extend this way like that. So I'll take T for 1 unit, for that unit, and subtract the other T. Let's say if it's T for 4 units. This one is so close to this one. Just a minute. Dealing with the technology issues also sometimes troublesome a bit. Something hung up a bit somewhere there. But here, let's say I want to get for 1 unit, I'll get that and subtract. But I wanted to do for more units. I could come here and maybe fix that later. So you could get that. You could take a T, I'll just use maybe how I know it quickly. So you take T maybe for 2 units, or T for those number of units that you have. And then I, of course, deal with what I am going to cover with that. So subtract T for 3 units, sorry, T for 3 units, you subtract the T for 2 units, and you get, it gives you how much was spent on the second unit. Now it's not coming out properly there. Just maybe cut off this and forget about this. Just excuse me. There is somebody who wants me to admit him. So I'll take that. Oh, I've got what the problem was. So if you take that, you can take T like for, let's say for 4 units. I want to calculate T for maybe the 3rd unit. I will subtract T for the 3rd unit. T subscript that. So that's what we get what we calculate incremental. Now, the reason I'm emphasizing on this, even the question you have in the past paper, it has interval. You have to know how to calculate incremental. So you'll take T, subtract T for the 3 units. I'll use that quickly, maybe to move ahead and maybe forget about it. So you subtract that and you get what it is. This is T for 3 units. I don't know why it is behaving that way, but I can cut off and forget about it. So T for the 3 units. Once you subtract, you get T total for third unit. Third unit means the 1 unit. It is the 1 unit you are calculating for, meaning you want to calculate how much hours was spent only producing the third unit alone. So you take T for 4, subtract T for 3. And I think that's most likely what I wanted to say. And it happens systematically to that any other area that you may feel you want to apply incremental. Now, in fact, as I said, the reason I'm struggling to explain that is because even the question we want to do in the past paper has that, where the students are supposed to calculate what will be incremental in form of those figures. So you take for the 4th unit, for the total of producing 4 units, subtract total of producing 3 units, and you get the difference, and that is what it is from that. So you will get some XX data, and then you subtract some XX data, you get total, hours for making the third unit like that. So anyway, just to go back here, I can fix that here. So I want to get this column called incremental. So to get that column called incremental is possible. Incremental is possible. How? I could take, as we said, 0, 100, subtract 0. That one is not a problem. Or take the T, because it's possible to calculate if you want to. So take this, multiply by this, raised to 1. And raised to total. Total factor is 1 plus B. B is this one here. So you close the bracket, you get what to give you, minus when you produce nothing, because at the beginning there was nothing. So which is, of course, again, this multiplied by this raised to the number of units, which was 0. The number of units, I'll put 0, don't worry. I change that one to 0, but you'll have 1 plus this factor here, which is, of course, what we get for that. But in this case, because I should put here 0, because they produced nothing, so you get it is equals to 100 for that case. Now, that will happen in all that cases, and you get what you call incremental in form of what it is. So incremental can be calculated. Now, I don't want to go through all the formulas, but I can say it can be calculated by changes within that. But if I want to do that, I can easily do, because I can simply lock this, and I lock what is relatively similar here. This remain the same. So as we have that, this will be changing every time you'll be dealing with that. So that in terms of that, if you run down, they should be giving you some changes which happen. But unfortunately, they are giving you the totals because of the 0. So maybe the idea is, instead of this, I should maybe put 1 there, such that they change a bit different from that. So it gives you the incremental, which is, of course, you will get as you try to get. And this one here will be relating to that. So anyway, I'm just trying to develop the formula there, which could be used. So you may use that, can give the same. Those who have calculator could confirm that as it tries to move around, and it gives you what it could be from that scenario. I think the problem also could be maybe on the fact that this one here did not remain the same. So maybe it should remain the same throughout as we run through that. So there could be that, which will give you 60, and the rest will be giving you also that. I think I did badly, but it is what I could wanted to do. But the formula does give you, using Excel, so you're trying to see what you can do there. So the formula has to give you. I think I did not lock these also. That's why it is kind of doing that it is. So if you do that, you should be able to run through think it's not working. My formula is not working. I'll investigate later in the future and understand what really went wrong from that case. But if you check, then if you do it with manually, because that's why it's a good thing to do manually sometimes. So when you do manually, then you'll notice it's supposed to be changing as you go through. I'm still studying what made it not really work for that, because this worked. This one did not work because maybe the changes were not really good for that case, but it went to 2 and all that cases. So anyway, if you do properly, if you apply the formula properly, those who are doing practically, it should be able to give you, because I think my head is not getting where the difference is coming from, but should be able to give you the incremental as it is as you use total. So we use total to get incremental. So make sure you know both formulas. The difference is not big. The difference is not big, it's very small. It is simply on a certain aspect, which is, that could be the case. And then that is it. I think here, the problem is here. I should remain with the 20. That could be my problem. I got where the problem is. I should remain with the 20. You had locked the wrong figure. So if you do that, to give you the incremental. So I got the problem. So I was still studying that. So the incremental will be the same as those as you deal with that. So unless there's anybody with a question on formula, if there is nobody with a question on formula, that's how it is applied. We can go to the question in the past paper and do it and see how it works. Question. So I've given you the two formulas. This one is to get totals, which is this one here, which is what
Excuse
I could
me,
say.
sir.
Yes.
For me, I have like two questions.
Yes, you can ask.
Yes, question one is using the other formula of y equivalent to ax to the power b, where we have y as cumulative time or cost per unit. So you want to mean that on the first unit, y is equal to a, because y is the cumulative time to produce the cost per unit, and the a is the cost or time to produce first unit. So when you are producing the first unit, y is equal to a.
Yes, when you're producing the first unit, yes, the first unit is a in the formula. When the first unit is a in the formula, let's agree that way. And it is actually the beginning of learning. Most times when you're solving these questions, you need to have a, because a is the beginning of where you engaged the person in the process of learning. So a is usually the first hours spent on making the first unit. That is a. Or it could be also cost per unit, because through my process, I have noticed also when it is cost per unit, cost per, of course, of labor, cost of labor per unit. If it is cost per unit, also it can work. Cost per unit.
Okay.
It can, most times it works.
Then another question I had.
And the cost per unit, of course, it remains the same. It is assumed to remain the same. Yes.
Okay. Another question I had is like, if for example the company is producing like 4 units.
Yes.
And then they ask you to calculate the total time to produce all those 4 units.
You will use this formula. If you are asked to
if you use that formula, you get y, and that y is you get the cumulative time to produce time to produce the first unit. And they're asking the total time to produce 4 units.
Total time to produce 4 units. Now, if you use y will give you average. If you use t will give you total exactly. T will give you exactly. But if you use y, it's not bad. You still have to multiply, because y will give you an average, which is per unit. So you only need to multiply with units to go to the total. That is the idea. So you can still use y to go to totals, but you get the averages and then multiply, because that's what it gives you. Like you notice that this will give averages, but if I multiply with the 2, it goes to 160. This will give me average here. If I multiply with 4, it goes to totals. So I can use averages to go to totals, or I can go directly to totals and get my answer. So that is how somebody came up with that formula. It's called learning curve formula, which is what you, if you ever find a question on that, it is the one you must remember to use in terms of that. Any other question before I go to the past paper? Remember, there are other units inside here. For example, if they ask me what is incremental of what is the you have to be very careful about the language used to when you are using this learning curve. If they say what is the cost of the third unit, it means it is not total. You have to calculate total of only one unit referred to as third. If they say fourth, then you have to know, you will have to find the cost or the components of only the fourth unit, meaning you'll calculate total of 4 units, subtract total of 3 units, and you get the cost of making the fourth. So you have to be careful about that, because there is the units, how they are defined with what follows makes sense, or what comes before. If they say the total of only 4 units, then it means you don't need to do incremental. But if they say the fourth unit, you have to apply incremental, no shortcut about that. So the concept of how the language and it is defining the units and requirement will always tell you what you need to do. If they say fourth, it's not the same as the total of 4 units. If they say third, it's not the same as total of 3 units. And that is the case. So anyway, and if you do that, you get what you need to get, and that's what it is from that scenario. Now, if there's no question, I think we can move ahead to the past paper. But because of time is why I'm moving directly to the past paper, because as I said, I need to move directly to the past paper. There are examples here, so I don't have time to go through all the examples. In relation to that, they have even the answers there. You could see how they do calculate that. If you are stuck with maybe we have only not done the examples enough, the examples there, some of them are applying those. So there is some answers, if you find you kind of did not get maybe enough of what the example was bringing, sorry. So you notice the examples there, even formulas showing how to do that, and with the answers connected to that. So I'll share this for that purpose, because I don't want to focus on examples while I have regression and high-low and time series waiting for me, including linear programming as well. So I think rotationally, I'll just move to the question immediately and focus on it. So the question that I kind of have in mind is March 2022. The question is March 2022. In one way or another, we did something on March 2022. I think that is when we were doing some question about there was a question we were doing about, what was this? There was a question we did about, what was the issue? Decision theory. Yeah, decision theory. We did something about school, blah, blah. It was a good question because, and I say the reason why I picked it, because it is among the few questions which required you make a payoff table, and students have to learn how to make a payoff table. And I did that one as a way of showing how a payoff table can be established using that concept of what we had learned on that day. So in that question again, the question below it, I clearly said I'll not do it, and I did not do it. And the reason was that I left it for this reason, which is to do the learning curve. So now that we have some idea about learning curve, and nobody has a question, so the examiner has some questions which were tested for us to go through that. So I could go through that question. It is in March 2022. March 2022. March 2022. Check March 2022. There was a question about school and the capacity and stuff. of students. They are planning on enrollment of students. So they had this uncertainty, which created various analysis they need to do to make a decision on that basis. So this one is maybe not, the search here is not to my speed. So maybe it is taking time, maybe, I don't know, but I can also do manually quickly, and I move to where I'm supposed to move there and see if I can get there. Things take some time. Maybe I should give it some break for that case. But the question there was mainly, you were supposed to use the learning curve concept there. Now, unfortunately, there was no formula, or a formula is not given. So it's not like, I think in ECCA, they do give formulas. Maybe, I don't know if it's all, but they do give formulas, and those formulas are what it is. So it has decided to search. So it's a question on it's a question on what? Let me see. I've moved out. I didn't see it. Did I move too quickly? This is the issue verse. I think, is it much, really? Maybe I choose the wrong part of the paper. It was about the school. I don't remember if it was this one here, but I can check and see. I think this one we did recently, some issues, but there was one which was about the school. Let me check in my summaries, because I have some topic summaries issues. Let me check it as well. Maybe it can assist me to remember which part of the exam, or which page am I supposed to go to directly. I think it is, let me check, learning curve.
It is December 2021.
It's December
2021.
Oh, not much.
Hmm?
Yeah, you're correct. It is December. Question 3C, is it?
Yes.
Yeah, I got it. So question 3C, I got it. Thank you. I think I was searching, much was stuck in my head. So I'm supposed to search December 2021. Maybe I could scroll down and we read it through and see. So there's a question, we deliberately left it out. The reason I left it out, as I said, was I needed to make sure you get the knowledge. It should be here. I think I pressed here. Is this one? It should be this one. So there's a question we left for 8 marks, and the 8 marks can make you leave the contract of ICPAR. So 8 marks are good. They can make you have the 50 that is intended for you to get, and you can easily get that 8 marks. So it is question number 3C. 3C, this one here. We did some issues about it, and I think we went through that. And this question 3C, of Groupe Scolaire de Huye, private school which was operating in the Huye district. We did it somehow. Now, the only part which we left, I don't want to go and read everything else. The only part that was, because already last time we read, and even if you were in class, we did, as I said, whenever there's required, you have to connect required to what paragraph or what context or what body of the question as the concepts that are required, or as issues or subject matter that is being required. So that is the case. So already we know that. This, we already did it. So as I said last time, this relates to, this part here was about learning curve. This paragraph here is typically on the learning curve issues, and here it is how it said. So I'll read from that paragraph. Already we know the other part we did, and it was used whatever it was used on, or whatever we used that part for that. So they've said again, during the period, the school will need to tailor the students' uniform by using casual tailoring staff. The head teacher is aware that labor cost may be reduced as the number of uniforms are being produced due to learning experience and tailor's efficiency. She's aware of how people become better and they become cheaper with time as time goes by. So she's informed about that. And then the total predicted uniforms are 7,000. The total predicted uniforms are 7,000, as you've seen there. So the idea is that that is what they are using as the number as per the number provided by economists in good economic condition. Now, the predicted labor cost for one uniform is 15,000 franc. And an analyst has indicated that 80% learning curve will apply for the first 6,000, after which constant production will take place. The headmaster wants to know how much he can plan to spend and charge for from the parents while enrolling the students. So he wants to know. So with the calculations, comment and advise the headmaster of GOH the minimum total cost he will charge parents, learning factor for 80% and is equal to the log. The log, already know how to calculate the log. They have told us that is the index, sorry. The index that is equal to an index of 0.321, which is a negative figure. So if that's the case, we can go to the question and solve and get some 8 marks for that and move to regression and the rest of high-lows issues and time series for that sake. So anybody who has, unless there is any question, if there isn't, we can go to the Excel and check it out, right? So I think in the Excel, I copied it somewhere. I don't remember which part it is. Let me check. No, it's not here. There's this one here. It is here. So I'd put here so that I can easily move around with it quickly here and solve it and have my the suggested solution that we intend to have from this. So let me solve it and then we see how it is and we move ahead and probably find out how we can handle it. So the total, the total predicted uniforms are 7,000. That was the most important issues. But of course, there's other data which I left, like during wherever they say the person knows about the learning curve and blah, blah. That is okay, he knows. But then the issue we were supposed to use calculating was this one here. So I copy pasted that here. The total predicted uniforms are 7,000 as per the numbers provided by economists in good economic conditions. The predicted labor cost for one uniform is 15,000. An analyst has indicated that 80% learning curve will apply for the first 6,000 uniforms, after which a constant production will take place, meaning the learning stops. Everybody knows there is as I said, there's a point where the learning is not, you're not learning much. You are actually, if you are learning, is like 2% or less than, or maybe even 0.000 some percentage. So that's the case. Now they've already calculated for us the index, which is good for us. For those who don't remember how to calculate the index, I've put here the B out is calculated. So all we need is, of course, to remember what they want for us. Now, the idea is this: if you check the question, you notice that they are saying there's a point where learning will stop. There's a point where learning will stop, and that is what we need to know how to deal with that. So if I sketch this is like a line here showing how things will be. Maybe we can use that as a part of understanding how this will be in form of what we have. So we have that. So if you check, there's a point after 6,000, the learning will cease. The learning will cease, and we need to apply whatever we can do. So there is a point here, and it's starting here, and then there is also, as it moves to that area, there is a point where it is also, going to have stopping, let's say like that. And immediately it stops there, there's a rate that will be used. And that rate is the rate that will be used to the end of this project. So there's a rate that will be used to the end of this project. And that is what we need to get there. So there's a constant rate that we may need to calculate, which is between here and there, you know. So that's what they tell us. It will become constant. Like you're not learning anything. You are simply going there and do the work and finish. And of course, there's a rate usually you finish with, and that rate is what becomes a constant throughout. It applies in life. There's a time when everybody knows you finish this thing at that time. That is how the best it has ever been. And that is how it is. Even like CPA is where we know, like even me, I can tell you teaching CPA, if you want to teach effectively, you need not 48 hours as stipulated by what you're supposed to do. You may need actually more than 100 hours or averagely, let's say 60 plus to deliver what would be quality. If somebody teaches under 48 in 48 hours, I don't know, it's impossible to tell me that it has delivered quality. It's impossible. You can't convince me about that. I've been there. I know it cannot really work when it is that way. Yeah. So anyway, that is the case. So we all know that, or we know even from your work, you know how long it takes to finish certain works. So anyway, from moving to that, let's find out what is our formula here. Now, I'm going to use the total formula, or I would use average, whatever it is. You tell me what you feel is comfortable for you, and we can always use that to move ahead. So our formula is that, as you may notice, is that we should have y is equals to a, let me use small a, multiplied by x raised to b, raised to b, and you get what it is there. That is an average. Of course, if you want to get total, we have said total is a multiplied by x raised to b plus 1. So that's what you have said again. So how do we go about this? We can go about this and use either this or this. If you use this, you multiply later. If you use this, you get instantly what you want at that point. Why do I need this? Because remember, I need to give the master figures, and the figures depend on the time or the factors that I'm developing here. And that's why those figures will be useful to assist in stipulating the cost of a uniform. So our A here, let's find our A. Our A is, of course, as you may see, the A we said is what has been spent on the first unit, and they have said it is 15,000. That is A. What is our learning rate, our LR? But already we have used it, so we don't need to even it because they have given us already the index is equals to that. Where does learning stop? Learning stops here at 6,000. They stop there. Learning stops there, after which it is a constant rate. So they say that the learning will go all the way to 6,000, after which is a constant rate, meaning that I think this 6,000 I should put here. This meaning that this 6,000 is where the learning stopped. So it means the learning stops between producing the 5,999, the additional unit. The sixth, if I may use that language again, learning stops on the 6,000. If you may put in the power like this, maybe if somebody want to put that, it stops there. But where does learning stop? It stops on the 6,000, if that is the correct English. Sixth, if I put that way, 6,000 unit. That's where it stops. So on the 6,000 unit, that's where the learning stops. And the 6,000 unit, to calculate it, how do you calculate the 6,000 unit? You will have to take the total. So how to calculate? How to calculate the constant rate? How to calculate the constant rate? You will deal with that. How to calculate that constant rate? To calculate constant rate, just a minute, let me admit somebody. Calculate constant rate, you will calculate T for the 6,000 subscript. So you calculate T for the 6,000. That is what you need to do first of all. So you will calculate T for the 6,000. Too big, eh? for the 6, I think is something small here. 6 for the 6,000, that is small. I think that is okay. T for the 6,000, it just stops there. And then you calculate T for the 5. T for the 5999. T for the 599, and you get that, and it gives you the difference. So let's calculate that. We'll calculate that later. But in the meantime, that is what I wanted to explain, the interpretation of that sentence here. It stops there, after which it becomes constant. The master wants to know how much to be spent on that. So we have our X, remember, is a variable. X can be either 0, X can be 1, X can be 2, X can be 3, X can be up to N. So X can be any of those, or any of whatever number could go there. So that is the X. So if you check here, we can use that. So let's fix that and see. So to fix that, we want to first of all find the cost. So we have 2 costs to calculate here. There is a cost from this point to this point, and then there is a cost. Oh, there's a cost from this point to this point, and then there's a rate which will be used here to calculate the cost that will move from this point to the future value. So you have to know that. There's a rate that you need to calculate from this point to that point in terms of uniforms, totals. And then there is a rate that will pick from here. There's a rate that will pick from here. This rate here is the one that will be used to cover all the others in continuous like that. So we need that rate to cover for any rates that will be realized from here, or cost of labor that will be realized from there to there from the tailor. So that is the case. And I think we're on the same page. If that's the case, we can move ahead and see how it is. So let me calculate now the first portion of this. So the first portion of this, before I fix this, because I've already explained that, is to calculate the rate between this to that point. So let's calculate the rate where T, the total cost, or you can use averages, as I said, total cost from unit 1 to 600,000. We can calculate that and use it, and then we calculate the difference of this. I think I could put more space down here. Here. So let's calculate that. To calculate this, we already said that we have A. A is 15,000. So multiply by the number of units. The number of units being produced there, X is 6,000. That's why I said it is 6,000. Raised to 1 plus, yes.
In our previous example, A was named after the time taken for first unit of output.
Yes, exactly.
So, but now A here you are referring to as a cost. So I failed to link
There's
the
where
two.
I said strategically also A here. I said it can also be cost per unit. And I've emphasized that again, that it can also be cost per unit. I added it, even from the formula given here. They have not given, you see, a formula which was given from that book, which was I got from, is it Kaplan or whatever. They haven't given that, but I've explained A, because based from my experience, I have done questions using also cost, and they give the same. So it is time taken for the first unit, but I explained here, you could see here, I said it's also CU per unit, meaning cost per unit.
Okay, makes sense.
Okay. So it can also be cost per unit. Now, there are questions you could try when you use cost, and you'll see they give the same answer. The only issue will be they will give you in money form, not in hours form. That's the difference. So that's why I took 15, because based on that, as I've explained, it is also, you can use cost per unit because it works. So anyway, the answer would be, you take this plus, not plus, multiply, sorry, with that. And since you multiply with that, you get, it will give you that figure. So how did I get this? Again, I took 15, I could put it here, 15,000, multiply with 6,000, raise this. to 1 minus 0.3219. And you have your figures there. So you raise to that. And that is to calculate units, which are, of course, as you may notice, 6 for the 600 units, you have that. That is a subscript. It's not part of the formula. It is just to say it is what you are calculating. You are calculating for the P units, which are 6. The units there are 6,000 as it is. So that is the cost from the first segment, which is this one here. So whatever you are getting is in money. Whatever we are getting here is franc. Is franc, sorry. I think I did the wrong issue. Whatever we are getting here is in franc. So it means it is the cost of the first batch of from 1 unit to 600 to 6,000. That is the first batch, which is the one now calculated. Now, if there's no question, I need to calculate now the batch moving from the second section, which is one I put in the purple color, which is what I need to do. And the rate that I need to use is this one. It means the learning stopped. He was not learning anything. He was like now becoming very mechanical. You know, when learning is not there, you become mechanical. You just step there, you just go there and do la 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 like this and go away. You are not even thinking so much about what you are doing as such, or even if you are thinking, it's the same pattern you are, or if you are thinking in the same way you usually think. You are not really, and if you are learning, is insignificant and cannot materialize into something you could factor in as a change of whatever you are doing. So we need to calculate now this. After we calculate this, we add. So for this, I'm calculating, I want to find the constant rate. Remember, there is a first batch. So I could call this first batch. The first batch, the rates of learning were different. The first batch, the rate of learning were different. The second batch, the constant rate application is that the rate should be multiplied throughout, and I need to use that, the constant rate. So those are maybe the distinction or the headers I could use to define the term. So this, the first batch, of course, with this different rates cutting through different areas or different issues, learning going on very aggressively, as you may notice that. You know, when I say different rates may bring problem because somebody may say, I thought it's 80%. Let's stick with that, say, first batch. So then the other one is constant rate. So the constant rate, we need to find that constant rate. How? We can calculate it by taking 15,000 multiplied by 6,000 raised to 1 plus negative 0, if you know, negative 0.3219. And you do that and you get what it is. That is what I'll do that. I can put equal to, and it gives me that, well, which is similar to already what you calculated anyway. So subtract this, you can easily come here, and just what you need to do is change this factor here, because other things are similar. So you change this factor to 5999, and you get is equals to that. I put too many nines, that's why. So you subtract, that is the constant rate. So this minus that constant rate, this is the constant rate that was used to produce the 60th unit. The 60th unit, this is the constant rate. That rate, or that's the rate which was used to produce a 60th unit. In, of course, is in franc, so you get that. So this rate is the one they use throughout to the end of what they are producing. Remember, they have to produce 7,000. So 6,000 is what is for the first batch, then the balance is 1,000. Because at the end here, they're supposed to have 7,000. Sorry, 7,000. So that's the case. So there's a difference of that, and that is what is supposed to be produced by that. So it is a constant rate. You don't need to apply this formula. All you need is to find the 1,000. How to calculate that? You pick 1,000, you multiply by this rate here, which is 618, and you use that because it's a rate, Remember, this is a rate of franc per uniform. Sorry. So you simply multiply with that and get what it gives you from that angle. So you do that and you'll have your data. It's franc per is per uniform. So you get that. So therefore it means simply take 1,000, multiply with the 618, and I get what it gives me from that.
Where did you get this 1,000?
Is the difference. The target, the predicted was the one to make 7,000 uniforms.
Mm-hmm.
So the first batch is already out, which is 6. So the second batch is the total, is the balance. They want to make, that's why you see I've added to this, because this is the total prediction. Total prediction, they wanted to make 7,000 based on the economy factors. Or given by that economist who say the better will be that. So that's the case. So you add this and you add that and you find is equals to total. So that is the total. That is the total cost of all uniforms. So if I want to get cost per uniform, I could get that, but you could just divide. But at one point, when I was doing that question, I found it was not logical, but that is the issue. So if you take this, that is not what I need to trust for that. So that is if you take this, they take the average, and he has to charge them the same price, because he cannot charge parent B this, parent C that. No. So he'll charge the same price, which if you divide by this 7,000, he gets that he will charge 869 per uniform. That is what you get from that. Unless there's a question, you get your 8 marks for doing that. Now, those who may use average, you have to multiply before you get the constant to get the totals, and then you subtract. So that is the case. Now, if there's no question, there's a question, I want to go to something else. You would wish to go to another forecasting technique and use maybe, so this is the cost per uniform.
Excuse me.
Cost per uniform, yes.
What's the difference between this new cost per uniform and the prediction of 15,000?
What?
What is the difference between this new cost per uniform, 869, and the first one, the prediction of 15,000?
The difference is that as you learn, your labor becomes cheaper. As it becomes cheaper, then the cost of labor turned out to be cheaper. And since labor turned out to be cheaper, then the cost of uniform went down. That could be the difference. Because as you said, the learning curve, reduces the labor cost in the long run. So that is the case. If you check here, you produce 6,000. 6,000 would be 991 for that case, if you do an average, if it was to be an average cost. So to be that way. But as you continued, you notice that it reduced, because at this point, it was now 618 throughout. 618 was what it was throughout. So the cost of labor reduced. As you may notice, in the process, it reduced by from that point to this, and it becomes more cheaper from that point. Probably, according to me, maybe they accepted the learning to continue beyond certain limits, and that's why the uniform became too cheaper for that. Because as I said, you remember, I developed an example here. I said learning curve has a point where it has to stop. Because here, if you continue, this figure can reduce to 0. If this one here, you remember, I did even an example there. And I said this figure is learning, as long as learning is reducing the hours, it can reduce to 0. So there was a weakness maybe from one point to another here and there. But for us, we were taught to calculate, so we calculate and that's it. Other things are thinking, overthinking, and that could be also part of what could be also questions which could be that. But when you look at it, we have done exactly as per what the concept would want us to do. So if you check properly, you notice that the cost, if they divide, the cost per uniform will be cheaper at it because they'll produce that uniform at around now what you have seen here, which is now, this is what they charge, 800 and something of all those uniform if you divide. So that is what I can say for that. But as I said, learning curve, as long as it continues, you'll find your rate keep on reducing, and it can become a dangerous tool if you use too much. Because you'll find you are now claiming, because which is a weakness also, you now claim that this person is now doing that work at 0.0 or is making even computers at a unreasonable rate, which nobody has ever made. It is not possible, because as long as it keeps on reducing the cost, the rate, you see when you get incremental is now negative, because you are going even to 0.0 something. Nobody can make average of 0.0 something, and that is not possible. So the learning rate, there should be a point where you should be able to determine that, and that is the case. So here, maybe they went beyond overboard. Maybe the learning should have stopped maybe at 2,000, because she took 6,000, which was the biggest value. You keep on learning. I don't know. The biggest percentage was learning. Because when you look at it, the uniform are 6, are 7. So if you are learning almost 3/4 of the work, it is kind of also something which could also be amusing. You see, almost 85% was a learning process. It is very serious. You learned almost the whole of the process. Anyway, that is just my thinking, but that was not asked. The question was asked was to solve it, and we have already done it. So anyway, let's go to regression and the rest of all those cases. Unless there's anybody with a question there, that was it. You get your 8 marks. As we said,
excuse me.
You can make comments as you wish.
Excuse me.
Yes.
You said this question is the March 2022.
No, it's not March. Somebody corrected me. It is December.
December 2021.
December 20. March, there is no question on learning curve. Actually, we have had only possibility of 2 questions on learning curve, maybe June and the December, June 2019. Those are the possibilities we have had such questions. So that's the case. Any question? Okay, if there's no question, let's go through the HILO. I think everybody knows HILO. I don't want to go through HILO anymore. We don't have time. I would wish to go to regression, but HILO is the easiest. All you need is select the highest and the lowest, subtract and get the difference. We did that one way or another. We've been through that. Next is regression. And there is example there for HILO. So I don't want to go through that. I'll just share maybe an example, but there's a practical questions I can use. Even regression, based on the time I have, I can jump on a question and do a question, and then we know. I know regression, most of you know, like this formula, how to get B or that, because regression and HILO, they give something called Y is equivalent to A plus BX. The Y is, this is fixed cost, this is the variable cost. So that's what they give in form of that. This is fixed cost, this is variable cost. Y is total cost. So it assists us to do that. They're expressing that. B is calculated as this in regression. So I don't want to take so much time on it because, as I said, statistically, you know, you may have covered it, and also it is not a big deal. All you need is a formula and work on issues. Now, there is a question which was set on regression and the rest. Let me jump on the question because I think everybody remembers this formula. It's not a big deal to kind of like go into the details. Based on the time I have, it's already 8:12, and I just want to do a question and move out of there, such that maybe I'll only do time series if time allows me on Sunday, and then I go, you know, need to wrap it up. But in the meantime, there is a question which I've seen somewhere, which was tested on that, which tested on those issues. I think is about regression. I was searching a question, and I think I saw a question somewhere there. This one is not required using regression. I wondered where they wanted required using regression, where they have not calculated for us. Regression, that is also the time series using regression. There was a question I saw somewhere on regression. I think it's here, GIL. It's about GIL. We can use this question here. This one here is the only question I know on regression in the past paper, and it is in 2017. Those days, questions were a bit crazy. They were long. They used to run all the way. It is here. Using linear regression advice. Maybe it's the only one I know. If you know any other, once you get this, you apply the same logic. The concept doesn't really change. It is just a formula and the application needed for that. So if you check, you have all that, we can easily move it. It is in 2017, 14 marks that was set. It's the only question I know if I was to go to the past paper, which is what is the intention now, because time has gone. We don't have time for examples and stuff. Anyway, this is a good question. It used, they say, using linear regression advice, MD of GIL on proportion of rebranding project that will be completed using net cash flow of quarter one beginning quarter one of October, beginning 1st of October, sorry. Cash flows of quarter beginning 1st of October. I think that's what I should be reading properly. Now, the question is about GIL. So I'll check where GIL is, and then something connecting to rebranding and the regression, and then I check the subject is. I'm not going to read all the question. As I said, during those periods, this is GAL, so it is not the one. I need to check where there is GIL. There is GIL. This is GH. So they used to call them based on the concept on the subject of being discussed. That is GH. GH, that means it is a something hospital. I'll check for the GIL. So the GIL starts here, so it means it's the GIL, and I think you could check that. So the following is for the GIL, which I can read and then use it to solve the regression question, and then I will see if time allows me to see what I can do. GIL was established in 1997. First of all, we have read required under the holding of GL and is located in Kigali Industrial Zone, with subsidiary in East Africa region as well as West Africa and Central Africa as it is. GIL manufactures world-class cosmetics in categories of skincare, body care, bath, mainline, color cosmetics. GIL market share, just a minute. GIL market share for skin care and body and bath products has declined for the last 3 years. But market survey results reveal that the decline is due to increasing demand for herbal cosmetics products despite huge investment in advertisement and promotion. Similarly, the MD has decided to rebrand the affected products to include herbal components effective on 1st of October 2018. This rebranding project is anticipated to cost a franc of 1,178.4 million. GIL is required internally to generate these funds as per the group policy. MD hopes that these funds will be raised within 4 quarters beginning in 1st of October, from 1st of October 2017 through reserving 40% of the quarterly net cash flows. So they need to reserve quarterly. So they need this amount, but they need to know if they can reserve 40% of the quarterly net cash flows. GIL quarterly output sales, advertising cost, and total cost for the period on 1st of January 2016 to 30th of September 2017 is given below. So there is cartons. They have quarter 1, quarter 2, quarter 3, quarter 4. There is these cartons in thousands, and this, and this, and this, and totaling to that. There's a movement of the sales totaling to this, and this, and this, and this. There is also advertising, this, and this, and that, and that. This total cost is given as such. Total cost is given as such. Okay. Because the other costs are pre-existing, management budget to sell 14,000 cartons and spend additional 42 million and promotion. Management budget to sell extra 14,000 cartons and spend additional 42 on advertising and promotion activities in Q1 beginning 1st of October 2017 in comparison to the previous quarter 4 that ended on 30th of September 2017. So that's what I said. I think this one is beginning in 2016. So we have that projection. So there's 2017. I'm just checking the dates to be sure that my thinking is correct. GIL recovers 80% of the sales in the current year and the balance in the current quarter and the balance in the following quarter. All fixed costs and 95% of the variable costs are paid during the quarter, whereas the balance is paid in the next quarter. The market survey has further revealed counterfeit in color cosmetic products, even though it has revealed counterfeits in color cosmetic products, even though GIL has not yet recognized any related sales decline. The MD moved in very fast to control the situation by making substantial changes in the color cosmetics products designed in Q1. These changes directly increase the labor hours taken to produce the color cosmetics, which decreased profits in Q4. After the changes, workers took 20.85 hours to produce the first carton due to decline in learning curve, and the workers were paid 2,400. The labor cost of 44 million was incurred in production of 12,000 cartons of the color cosmetics during Q1. However, GIL has planned to produce each quarter of the color cosmetics within 18.75 hours at a standard cost of a franc of 2,300 per hour. GIL acted against the group policy and allowed idle time of 1% to rest since it was intense quarter. Anyway, I think this is just some additional issues, not really affecting the whole thing. Kind of is here, ends here. This is maybe for something else, because I think it's mostly talking about maybe a variance issue coming through. If you may check, you'll notice that. But anyway, my intention is to focus on the regression for today. The idea is that they want us to use the regression issues. So if you go to the Excel, I had tried to copy paste it somewhere here, and it is here. So the question is here, and I think I can use it to solve what I need to deal in terms of that. So first thing first, required again. If you've forgotten required, it's here. This is a current 2017. It is in that period, and it is in December 2017. It carried some 14 marks. Now, is it 14 marks? Yeah, 14 marks. So you have noticed that they want to focus. They want to focus and probably achieve certain targets that they need to use. So the problem is that they want to use regression, or regression is the one that is being used in that area. So first thing first, let's look at it and see how to deal with it, and probably maybe we could solve other things that comes with it from that concept that we intend to apply from that. So if you answer the question, there is a target. What is the mission here? There is funds required. If you check, somebody told me not to move. I used to like doing this side, because as I check the question correspondingly, maybe I'll copy paste down there later on. But I need to do this way first, because I'm used to reading it directly here when it is close to me. Even in exam, when I used to do exam, I used to sometimes separate the papers, because you are paying for the papers, so you could separate the papers. Anyway, that is just me, and so I need to like put it close to me to see it, because sometimes one thing may not be realized. So the funds to be raised are funds, targeted funds or budgeted funds. The budgeted funds, because time has really gone, I don't know even if I'll finish the question, but the budgeted funds budgeted funds is equals to 78.4. Those are the budgeted funds in millions. So they were targeting to raise that. So the issue is that they want to use this quarter to see if they can raise that. They used to focus and see if they can raise that money. So how do we go about this? We can easily use, of course, this quarter 2016 is already given here. This is history. They want to use it to project. They want to use it to project quarter 2017, which is what they're saying at beginning 2017 here, if you check properly. So they gave us 2016 to use it to project the other future of whatever would happen here. So if I was to go through that, then the idea is that I think I'm trying to explain you understand. I'm trying to explain to you to understand what they wanted. So therefore, we need to focus using regression. That's what they want us to focus. What will be the cash in quarter in 2017? In that cash, they can easily plan on how it is. If you see here, they've said that's what they wanted to do so that they can focus in the next quarter. That is what we need to actually find out how it is. Now, before we do the focus, we need also to understand it is about cash. The focus, so let me put here, required here is that, sorry, just a minute. You know, those days, nowadays, they used to set one question and all. So it was not, the required is to use regression, regression to focus. So we need to use regression to focus. We need to use regression to focus and see. We need to use regression to focus the future. That is what it is, future, and it is cash flows, future cash flows, and actually net cash flows, net cash flows. So the regression is using net cash flows. Regression can use units, and cost, and the rest. But here they're saying we use what is called net cash flows. So I'm going to use net cash flows in my focus of that issue that I need to focus on that. And that's what I need to apply. So having that, the next issue is for me to apply that concept, and more likely that is what I need to target. I hope you get the point. If you have the question, you can check maybe to confirm what I'm saying there, so that it can easily maybe explain to you how it will be from there. So if you check again, that's what you need to do. So first thing first, we try to make how to do that focus. Now we want to focus using that issue. So working number one, let's start with working number one. So working number one, I have, of course, the analysis. I want to separate and find what is variable cost and what is fixed cost in this concept here, because I need to deal with that and find how it is that what is the variable cost and related issues, because I'm given total cost here. I'm given total cost here. I need to split it and find what is my variable cost and what is my fixed cost. Why do I need that? Because the fixed cost may not change over time. They will be paid the same way. The ones that will change will be the ones which are the variables and will change per unit. So I need to split this. So my working one is to separate the total cost between the fixed cost and the variable cost. So that's what I need to do. That is working one. Why? Because the fixed cost, they have said again, because fixed cost will not change. So I'm looking into that. I just need to copy paste this here and do the splitting quickly. So I'll paste this because I have it here. So I can easily do that. And that's a good thing. I pasted this quickly here. So this is connected to It has cartons. These are cartons. I think the cartons, they say they are in thousands. I forgot to put thousands there. So I'll just fix that, sorry. It is not, I did not copy this. I needed to copy this. So they are in thousands. So I could copy paste that. And that is the output that you have for that case, which is relating to that period. And I think I could easily maybe let me put in the table form what is that. Remember, this one is in thousands. So there are some zeros which are not catered for. I think this one is in millions. If I check back, I could easily get if it is in millions and use that. Yeah, it's in millions. This is in thousands. So I have to be considerate of that in my mind. So this one is in thousands, while the other one is in millions. So this is in millions. So I could easily bring, this is the total cost of all. So I think I could take that and use it to get that. So I want to get the variable cost and the fixed cost separated inside here. And that is my target. Now, based on that, I could use HILO or use even regression. They give the same because it's a short table. It's a short table. Like I said, regression and HILO can give the same when it's a short data. Like short may relatively mean this may relatively mean something which is this, like we could use that. So I could use that. So if you're using regression, there's a formula which you could use from that. So if you check that, this can give you that. So I want to get y is equals to a, y is equals to a plus bx. Y is equals to a plus bx. B is usually calculated. So B, you may need to calculate it. If you don't remember B, you can find B as a way of, maybe I can show you how B is calculated, but because I don't want to copy the formula, because of time interest, I can show you how B is calculated. Let me just snip it here, and then I bring it where it's supposed to be. I can use snipping. So B is here, so I can bring B just as a picture there so that we use it there if you've forgotten about it. So B is here, so maybe if you want to get B, B is there. So B is supposed to be that way. So I need to get B if I'm using regression. And if I need to get also probably A, if I need to get A, I could also snip it and I get what A is. A is, of course, this small segment here, and that I don't want to copy paste it. I'll type it probably later, but I feel like time is really chasing me on the tail, and I need to make sure that I move across there quickly. So we'll use that as we have this, and use whatever case it is. Which Excel was I using? Oh, this one here. So this is A. So A is that way. So you will get that. So get it here. What is our X? This is our Y. So we just need that. So quickly we can do that. We take these, we multiply and get the part of the numerators answers and done that. And have here is a total which is equal to that. So that will give us the totals of all that is obtained down there. So you get that, and that's what we have. So that is the total of X and Y, and you have a summation, which is equivalent to what we get there. So that is the issue we have there. Next is we need to get, of course, the other data. The other data that we need to get, this is XY. We'll get the total is equal to that. So I've gotten this part here. I need to get summation of X. Summation of X is, of course, this. Summation of Y is, of course, that. And then I have this, which is summation of X squared. So X squared, I could easily just call it that way. And I get what it could give me from that. So X squared will be this, as you may notice. That is the formula we use for that. So I'd raise this to this part here, and I get that is my X squared. And I sum it up. A good calculator can also do that one. If you use that, you can also get that. So you'll get that, and that's what it is. What else? I need summation of this. It's already, I got it, no problem. So you could usually get that. This one is already there, and this is already this part here. So we have all that, so we can get B. So to find B, as I said, I'll attach all the other issues later. So to find B, that is one way you'll find, that's the way you're finding B. So let's find B. So B is equals to, the numerator is this one here. Remember, it's multiplied by N. N is 4 quarters minus minus, of course, the other summations of the other data that we have there. What are the data? We have minus x multiplied by summation of these, and you get that is your numerator. Divide by the denominator. Denominator is 4 quarters. That is the frequency of the numbers they are appearing. So you have 4 quarters. Now those 4 quarters, you divide with it and get what you want in form of the cases here. So 4 multiplied by this minus this put in brackets. So that one put in brackets, which is this one here. And then you square it and you get what it gives you, which is equals to that. Hence, when you take the two, I'll put the formulas later, as I said, before I send Excel. But for now, I am in a rush to make sure that I get to explain how that can work. From that, you divide by this, you get it is equals to 75. Now, those who want to use Hilo, Hilo will give the same.
Sorry, sir.
Yes.
Why didn't you use these cells?
Cells has no fixed cost in it. Remember, from analysis, we said, we have said, this is what we have said. If you check the first page, we use Hilo here. In fact, it is put in a graph, in a table here, sorry. We use Hilo for that purpose. We use Hilo and regression for that purpose. Hilo and regression are used for separating. I put the main objective why I'm doing that. I want to separate fixed cost and variable cost. Why? Because if you check here, there will be units which will be changing across in the next quarter. So it means I need to know what is fixed. Fixed will not change. Fixed will not change in the concept of that issue. So this total cost here, fixed will not change, but variable will change per unit. So I get the variable, that is why I need to split this total cost here. Here, advertisement seems to be changed. The advertising, it seems like this one here. This was for that. As you may notice, this was for that. So advertising, they have put the number of units, and it seems to be also changing as it is at every time of or every level of units. So the idea is that I want to separate the unit, the total cost. Sales doesn't have fixed and when you look at the equation of sales, it is simply units multiplied by what? Quantity. There is nothing fixed in sales. So that's the idea. I can't fix sales like that. Sales is totally a variable component. You have to make units and you have to sell units to make money. Is it? So it is a variable by nature. Okay, if there is no question, but I realize also this question you can use Hilo, although they did ask. You can use Hilo and it still work because it was a short question, a short data. You could use Hilo. Hilo, if you pick the highest seems to be that, because if you come here and say, I'd wish to pick what was maximum among this, it will tell you is that, and you pick also what was maximum among this, it will tell you what it is here, which you could pick that and use it. Maximum is that. If you want to get the minimums, you could pick the minimums, which is the lowest, because that's what Hilo use. And it could easily give you the same answers. But before I send it, I'll put in details properly. But for now, I'm just trying to show you that Hilo can be used in a quick way. If you take the minimums, the lowest points, which are here, you could find is equal to that. So generally, if you take this minus to get the numerator, you get the numerator is equal to that. Find the denominator, take these minus the lowest, you get that. When you take the two, this one here, divide by this, it tells you 75, which is B. And B, it means this is franc per unit, what you get there. So it is the variable cost component. But I can find fixed. I can find fixed. Fixed is A. A is computed as average. A is computed as average between summation, which is calculated as summation of Y which is this one here, divide by, yes, please.
By using high and low, I get it, but the way you used the other method, come again a little bit.
The way I use the other method is more regression, which I'm saying is all about formulas. And the formulas regression, I'm sure, is not the first time any student is encountering it, as I said, because regression is all covered in bachelor's or in academic, whatever, and even in business mathematics in the lower level of this CPA. So I use simply the formula to calculate the numerator, which, as I said, I don't have time to like put one by one. I'll put them later for that sake. But for now, the total is this, which is the total, of course, of course, this summation multiplied by 4. So I'll put the details probably later, and then minus the summation of x, which is of course multiplied by summation of course the x, summation of our x. As you may check, our x is there. Summation of y is this one here. You get that. Then divide by the denominator. Denominator has n is 4 times, which is 4 quarters, multiplied by, of course, the summation of this squared, which is already we have here, and minus the summation of this in brackets squared, which is this, of course, square it, and then you get, it gives you that. So if you divide, it is this, divide by that, and you get 75. That's what I need.
Yes, thank you. Thank you.
Okay, for A, it's an average of y divided by average of B, which is, B is, remember, B is a rate, total of variable. So for y is total of total y, how you get y? Y, remember, is not y, sorry, A. A is fixed. A is fixed cost. Commonly, A will be fixed cost according to our analysis, but fixed cost, which you can call FC, is equals to total cost, which I can call this subtract total variable cost. So this is the same here. Total cost is, but here we use average. They use average, that's the way they divide by n. And here it is average of also the what? The average of the variable. You total all the variables, which you take B, multiply by summation of x, you divide by that. Let's do that for this. I think you already know that. So y is equals to this, you divide by 4, that is the average of the totals, subtract the average of the variables. The average of the variables is B. B, we already have it there, multiply by summation of the excess, which is this one, the units, and then all of this, if you put it in brackets, it should be divided by the number of, sorry, it should be divided by the number of times there to get the average, which is divided by 4, and you get that. So that is to say that is the fixed component of it. And if you want also this, you can use HILO. HILO will give the same, because if you pick any of these, they will give you, you pick fixed cost, you pick total cost. Total cost is that, you will do that. So this is on regression. For HILO, it will be the same. HILO, you pick like an example, total cost is that, subtract this variable cost, multiply by the units at that level, which are these, it tells you is equals to that, which is the same as that. So it is gives. That's why I said last time, HILO and the regression can give the same answers if it is a shorter data. So anyway, we progress, and I think now I'm done with that. Unless there is any question. If there's no question, that question was 14 marks. But if it's me in exam, I think I'll have left it, because it went through a lot of process to get that. And I would have sorted maybe to do other issues. I'll come to it maybe later. But I have just to do it maybe for this demo, for the demonstration of what question has ever been said on that in terms of this. So that has been my working number 1. And that can assist me to separate variable cost, because now I can easily find what is the variable cost of each quarter, because I need to focus the next year, and then I can find what is the fixed cost of each quarter. So the variable cost, I have them now. So it's possible for me to do that and use that as related to that. So I know how the variable cost is changing, and I don't have any problem with that, because variable cost is simply this multiplied by the units relating to that. You get what is variable, and it runs down, as you may notice, like that. So variable cost is simply that, and if you lock this in, because that is a constant, sorry, I think I should unlock 1, 2, 3. So unlock that. I think I should have locked this. So if you lock that, you find is equals that, and the rest, if you run down, you'll find they give you that. And fixed, of course, is the total of this, subtract that, and you get what you get as fixed, which is, of course, similar in all angles. So that's the case. I've splitted that. I can move to the next issue, which is, of course, there's sales.
Sorry, sir.
Yes, please.
How do you say this total cost is fixed cost while it is changing?
Yeah.
You are saying that this total cost is fixed cost.
No, total cost is not fixed. Total cost is variable cost plus fixed cost. Total cost. If I said that, then that was if I ever said that, that was a slip of tongue or something I may have said, because I can't recall where you're saying I said that, but let me presume that if I said that, then it must be a slip of the tongue. Total cost is equals to fixed cost plus total variable cost. Total variable cost. Total cost can only be equal to fixed cost if there's no variable cost. But in this case, it is total cost is equals to fixed cost and variable cost, generally, or comprehensively. Unless there is no fixed cost, then total cost can be equal to variable cost. Unless there is no fixed cost, unless there is no variable cost, then it can be equal to fixed cost. Either way, that is the case. So if I say that, I'm taking that back. I don't say that, but I don't think I remember that. Yes.
How did we find this TVC, total variable cost?
It is already here. You have variable unit per unit here. You know that this will lead you to getting, I think it's not the first time you know that I said if you start again, because variable cost is the easiest part of this. If you want to get it is here. We got a rate already. B is a rate. B is a gradient. The rate is 75 francs per unit. Then find where the units are. The units are here, multiplied by the rate which is here, and you get your variable cost. So we already have it.
Yes.
Yeah. Okay. So the idea is that is it. We can move to the next cells. Now, because we need to now, somebody was asking about cells. Let's focus on cells and see what is all about cells. Why am I focusing on cells? The examiner here wanted us to use net cash flow to focus the next quarter. After I focus the next quarter, I determine how much funds they can collect. If you stick it is here, they said again here, anybody who maybe doesn't know what I'm doing, what we are doing is this. They have said that they want to collect some funds to finance this. So they have said that MD hopes that these funds will be raised within 4 quarters of another year, which is 2017, through reserving 40% of the net cash flows. So I need to get net cash flows. So I'm working towards getting net cash flows forecasted for the next quarter. So what I'm doing is to focus what is the next net cash flows for the quarter in 2017. And that's why they have given you for 2016 to develop what is the variable which I'm unfixed, which I'm assuming will not change. They say gives quarterly output, sales, advertising cost, and total cost for the period of the previous year up to this 30th of September is this. So they've given us the previous data. Management budgeted to sell 14,000 cartons and spend additional 42 advertising promotion in Q1 beginning the next year. So they want to sell 14,000 to sell 14,000 cartons and spend more advertising amount additional to what they have been spending. So they say 42 on advertisement and promotion in Q1. So Q1, they'll begin with additional of 42, maybe from, I'm presuming, from additional meaning from quarter last, which is Q4. In the previous year, even they have said, in the previous year, in that quarter. Then gear recovers, so just a minute, gear recovers, as you may say here, they say gear covers 80% of the sales in current quarter and the balance in the following quarter. So 80% of the sales will be covered in the first quarter. That is the cash. And 20% in the next quarter. All fixed cost. That's why I separated and variable cost. So I need to separate that. If you are asking why I was doing that, because I read this and noticed I need to find what is fixed because it was not given. So after reading that, I noticed I need to find what is fixed cost and variable cost. Are paid during during the quarter, whereas the balance are paid in the next quarter. So I feel like the color yellow is making sense to me. Red is confusing me a bit. You know, maybe I'm colorblind, I don't know. But that's the case. So the idea is that let's do workings on recovering cash, working two, because I need that to focus on how they will recover that amount, how much they recover. Working two. Working two is that there is a sales, which they have said the management budgeted to sell extra 14. So we need to, of course, use that for that. I need to notice if there will be, we can call it a cash flow, cash flow recovery matrix, and use it. You know, cash flow recovery matrix and use that for this. So there is Q1. Let me call it Q1. I could easily, or let me just copy paste this because I have already this. I can copy paste this to avoid duplicate me typing maybe what I need to do. So I have this. Those are the quarters there. There is Q1, there is Q2, there is a quarter this, and I think I can space that. And then there is that Q3 for that case. And even you may need Q1 maybe just here again to appear for purpose of just measuring, because they say they recover in some years. So this is sales recoveries or cash flow recovery on the sales. On the sales, this is on the sales as it is. So again, if you check again, the sales are running per quarter. So I need only to display here the quarters running 1 to 4. So I need to recover. So to recover here, let's see how much I can recover in each quarter. And I would easily notice what I need to deal with that. So if you check, this is the sales. The sales there in Q1 is equals to this. They have said they can recover some cash, which is 80%. Which is 80% of that. So they can recover 80% of that. So that is what it is. They can recover 80% of whatever they are selling from that factor that they have from this. But remember that according to the other year, which they say that the management budgeted to sell extra 14,000 cartons and spend 14 million to advertise. So it means they will do more advertising, and more advertising will lead to more sales. So this is the current sales. So they want to advertise a lot to make more money to fund whatever they want to fund. So I want to find what is my average there. So because I need to find if they sell extra of this, what is the price per quarter? Because I don't know the price per unit. We don't know what is the price per unit from that basis. So I may need maybe to find what is the price per unit and use it for that cases. So that's why I'm trying to find what it will be from that. But in the meantime, that is what they will get for this. The other one will be covered here. I'll add that later. The other one will be covered in the next period. So this quarter here will be covered 20% here. So they want to sell extra. Let's find the per unit here. If you take this, you divide by, of course, this, which is, of course, this figure here is, of course, multiplied by thousands because there is zeros which are left out. I think even the sale is multiplied by millions. I don't remember. Maybe let me check again. Where am I? Where is it? What is that question? I just need to check where it is from there. That's why I told you that question is the only question, but it's one question which if you were to focus on, then it will not be an easy question for that. I think it's not here. I don't, I wanted to check where it was. Just a minute. Where was the question? Okay, you'll check for me if it is in millions or wherever, but I think money was in millions. I think money was in millions. Let's go back, use millions. I'll check later on because time is moving. So it means this was in millions. So yeah, it is in millions, exactly. Sorry for that. So it is in millions. So it means if I was to put anything, then I should put also the millions back here. So that could be the case which I may need to do. So if you want to put the millions, then you may do that and get what it is. But because figures are in millions, let's leave it that way. Let's just divide and use as it is. Let's divide as it is. So that should be the rate. So they want to sell more extra units. So more extra units will be 14 multiplied by, of course, this rate here, which will be in the Q1. So they will collect that as multiplied by 80%, and that is what will be collected in. Sorry, that is what will be collected in that period. So they'll multiply that, yeah, multiply by 80. So they'll collect that. In the next period, they sell also more 14. If that is the case, if I'm presuming is additional to that, so multiply by 80. Remember, as I said, one thing is that the standard, sometimes this topic, which is called strategic performance, has no standard. So you may differ on the interpretation, but that is the case. So they have that. That is the idea which they are saying there, if I may interpret that. Then next is that they want to recover. The next sale will be recovered here. That is in Q2. So Q2, again, they will sell extra 14 cartons because these were cartons. So they'll sell extra 14 cartons. I think I did even an error here. I should remove zeros, because we are removing zeros on the cartons. So they should move zeros so that you maintain the way it is from that case. So it should be that way, if I'm not wrong. So again here, this is the case here. They want to sell more extra cartons. So more extra cartons will mean more revenue. How about if we do this way? We just divide here and get what is average for each carton being sold. And then we multiply, we take 14. That could be easier because I feel like doing Pomplus is making me, I can easily forget. So what I do, I just get 14 multiplied by this, and then I plus what is already existing. Because if you say there's additional, I think I can get extra updated cells. Maybe I could do that, is it? So that I take this as a selling price, which I get per carton, and then I upgrade this is extra additional selling price that will make. Maybe that can be better instead of fixing it inside here. Then I come here, I get that they'll have this plus the 14, which they will sell, and they have extra of that, is it? That will make sense, such that if I pick my 80%, 80% will come from that upgraded cells. That is easier. So that would be that. And then this one here, I pick also from my 20% there, I get that. I proceed like that. Next, I pick like this, I multiply by 80%, and I do my matrix for that. They'll collect that. I continue with the next, I collect what is called 20%, and I move on like that. And since I'm doing the total on this side, and I do the total on that side, and I get what will give me, which will be, of course, that. So here, they'll collect again 80% of this in this period. So they collect 80% of that, and that will be that. Here, they collect also 80% of 20% of that, and the 20% will be that, confirming it is the same as that. Similarly, here, they'll collect 80% of this, and the other 20% will be collected in the next period. So it's 80 there, and you move on like that. This is basically what they were talking about. This will be 20% collected there, and it makes sense to have that, which should add up to the total sales that should be here, as they say they'll do additional in the next quarter for that case. So that's what I'm taking into consideration. if that is what I needed to do to get what I have for that. But again, I need to recover the cash. So the idea here is that we are trying to focus what will be the cash they will collect in the next quarter. Now, since they said in the next quarter, they will sell more extra units. So I need to find out how will be the cash collected. So if you add that, this in quarter one, this was a question with the budget inside also. In quarter one, they'll collect it that way, and quarter two and subsequently that. That is the total quotas they will collect for, or total amount they'll collect from that basis. And that's why sometimes the previous questions were usually like that crazy somehow until they reviewed it and changed maybe some things in there. So that's it. So if you get that, that's what I think you should be getting from that. But on the second thought, I was thinking that maybe we should not factor in 14 because 14 is part of the next budget. But let me think about it because I'm thinking maybe I should not factor 14 in it. So the next issue is let's get the total revenue. Total revenue is an issue here also. Total revenue, not total revenue, sorry, cost. Total cost. Total cost. Total cost also cash collection. Cash collection. So total cost cash collection will also be dealt with that way. And I think that is what will happen here. We'll have, of course, the quotas running across here in the period here, running to that. They say they will collect that. So it is like a cash budget we are doing actually. And then that is a issue relating to that. Running down to that area like that. That is 4 quarters. So pay, as you may notice, we'll get the totals here. They're saying that all fixed cost and 95% of the variable cost are paid during the quarter, whereas the balance is paid in the next quarter. So they jump only 1 quarter and pay that. So 95 is paid, and that's why I was separating to get that. So if you check the variable cost that we have, we got it here. We got the variable cost that we have, which is this one here. Is this one here. So part of it is paid in this quarter, and part of it is paid in the next quarter. That's what they are saying we need to use to get that. So if you check, let me do that and see. So, but remember, the variable cost will be updated because based on what we have, is that we have introduced units. We have said that they will sell these 14 units, multiplied by the 75, which is that. So variable cost will also be updated. Since I've updated sales, it will just make sense for me to update the variable cost. So this is updated variable cost. Because I've said the sales, they have said they will include that 14 in the next quarter. So we'll use that to get what it is here. And this is what it is. That's why I was telling you if it was me in exam, I can't focus on that. I'll have to choose another question to do, but that is what it required. It is only 14 marks, but it is only question which is on regression. So multiply with this and you get what it is. And that is to give you, of course, the total, which is summation, of course, across that, which should be equal to that. Similarly, that will happen to the rest. They collect 90. And remember, fixed cost is paid immediately in the month, the whole of it. So we don't need to spread it as a matrix. So this one here, we can spread it. So we have this, we multiply by 95%. And of course, the balance is, of course, multiplied by the other figure, which is, of course, multiplied by 0.05. And we have, of course, the total, and we run down like that. So it is a cash budget we're preparing, actually. So this question involved regression and budgets, cash budgets. If anybody had a question on cash budget is an example of what is actually happening here. So next is in quarter 3. Sorry, let me admit somebody before. I know people are getting now very tired when they see this question because it is not an easy question to go through for 14 marks, but that's what it wanted. That is, they collect that, and that is what it is for that. So they have, I hope I picked the correct issue because I'm seeing it is bringing like it is a big figure. So it is this one here, you multiply with that. Next is 0.05, you multiply with that figure and you get this will be of that figure, and you have that, and your total you will get that. Lastly is that they collected in the next quarter, which is this is like a stairs. So best stairs, but in descending order. So that is equals to that. So multiply by 95, you get the rest. And similarly to the rest is that if you do that, you get what it is there. You get, it is this one here, and multiply with the 0.05, and you have your data there, which is equals to that. So that is the cash collected in quarter one. That is the data collected, cash collected in paid in quarter two, cash paid in the rest of the other quarters. Why don't I just drag this to get that? So we have made a cash budget after we started the regression to separate the issues. So that is the case. So remember, using regression on proportionate of these, you need to do that. So I've already calculated that, and I've already used regression somewhere, and even I showed how to use ILO to split those cases. And that is the case where you can split the fixed cost and that. Fixed cost is not an issue. All of it is paid within the same period. And that is what it is. So you can make a cash flow budget. So how do you make a cash flow budget? A cash flow budget, I can make a cash flow budget, and we see a cash flow budget. So I'm going to make a cash flow budget for quarter one. And the cash flow budget, let me punch this inside. Make a cash flow budget for quarter one, cash flow budget up to quarter four. So this is what you can use and find out if they will have enough, to use from that scenario. So I need to make a cash flow budget. So it was regression was to use to give us to split it, and then we make a cash flow budget and see. So there is cash flow budget for also those. Now this is a cash flow budget that we need to make and advise on that. No, here it is not period. I think here it is the components make that. So the components making cash flow budget, one is sales. So you have sales collected. Apart from that, there's no other incomes. I could leave 1, 2 spaces in case of any, but less the variable cost. Less the variable cost, less the fixed cost. After you less the fixed cost, you will get net cash flows. So you will get, let's say you'll get total cost first. Let me go step by step. After you get total cost, you will get now the net cash flow, which is what it is. Remember, we're not doing an income statement. We are lessing fixed cost payments. So these are payments. So actually, we are lessing payments. We are not lessing just anything else, but it's variable cost payments. So we want to get that. So these are payments totally. So come here, pick them from up there. Like for quarter one, the sales is already there, and you could use that. Sales is this one here. For quarter two, sales is that one there. So run this approach and get that. So this will give you the total receipts, because we need to get the total cash from receipts, total receipts, we call it receipts, or whatever you're getting from that. So you will sum up that, and you get, and you advise how much they will collect from that scenario. Oh, by the way, before I forget, they were saying they will spend 42. Because I'm using Excel, no problem. I forgot additional of 42. Add here 42 million. Add there 42 million. I forgot to add. I've just remembered there was 42 million that was supposed to be added across there. So add 42. Add 42. Before I forget, there was additional cost of 42 to advertise. Is it like is it a variable? No. It should be added on the fixed. When you think about it, it is not changing. It is come to the second thought of it, means that when I think on the second term, or my thinking tells me that I should add on the fixed. So fixed will add that. Anyway, we can add down here. No problem. We can add down there. It is not variable, as it is not changing by anything. It is just what they advertise and they use it. So variable cost will pick this. The good thing I've remembered before, I could have, not factored in. We have all the variable cost, and we have also these ones here. And in regard to that, we get, these are all the variable cost and how they move by the cash matrix. Fixed payments. Fixed payments, We have we got the fixed payments, the fixed cost. They said this one is in millions. And this one is also in millions. Kind of tricky. It's only 42. It look like a small figure to be noticed if these are in millions and this is in millions. So I don't need to convert to thousands. So I could easily add it there and forget about it because the fixed is this plus 42. If it is that small figure, because I thought maybe it is the other figure, there's thousands to be added. So it's 42 for 2 based on that, because all the other figures are in millions, by the way. So if you do that and you get the totals, that is the total fixed cost, the total cost, take this minus this, and you get, that is the net cash flow they'll have. Oh, by the way, I forgot to show the reserves, because the net cash flow moves, so it becomes opening and closing. Anyway, these are the net cash flow they will have. You can total them here. You can total them here and get the net cash flow they collect will be that, which is equals to that. So there's the net cash flow, and it seems to be enough maybe to cover that, because I can think the way I'm thinking it is, if it is in millions, then it should be able to give us that case from that case, from what we have. But let me check again. There is something they said. Let me see. The regression was to focus using what? They say that, there is the net cash flows. What was the regression supposed to use? So they have said that they wanted to, they raised the first quarter through reserving 40%. Oh, so they reserve 40, not all of it. The other is used. They say the MD hopes that these funds will be raised within 4 quarters, beginning from that through reserving 40%. So they reserve 40%. It's not entirely all of it that is used. So it's 40%. So take 40% of what is here. Here you are reserving nothing. I don't know. Here, can you reserve what you don't have? I don't think there's anything to reserve in the negative area. So you reserve only 40. So it is 40 of this. I don't think here there's anything to reserve. Can you reserve a negative? Unless, let me just use it for the sake of thinking, and I don't want to overthink so much. So there is that. So there is 40 throughout. So they reserve 40, and 40 is what they sum up and use it for that. So it will give them 2,000. So there'll be enough funds maybe to solve that issue, which is related to that. So they'll solve the whole of it, because as far as I'm concerned, they'll collect this, collect that, collect this, which when you add, it is 2,000, and it is 2,000 is in millions, so it will be able to solve this. So what proportion will they cover? Because they ask on the proportion of the rebranding, advise the MD of GIL on the proportion of the rebranding project that will be completed using that. So the cash they collect can cover a huge percentage of that, because what proportion will be that? If you check, we have the total. What is the total budget? Oh, this one here, which is that. I can bring it here. So if you compare, they have this divided by that. So they'll cover almost all of it. All of it will be covered if I use that. If I use that as a basis of understanding what they were saying in that question. Like I said, that question required some in-depth thinking, and it's 14 marks. So 14 marks may come through the struggle of dealing with that. So if you check, that's how much they can provide. If there is anything they can provide for that, they can provide that amount of cash. I hope I've added correctly, because I've added this. This is they said 40% will be reserved. So it is 40 of that, 40 of this, if that is the case, and then 40 of that. So it will be able to cover all of it. So the question is done. Unless there's a question, I'd want to stop there. It's already 9 past, and some people want to go somewhere else. So time series, we'll find maybe another time. If you don't do it, I think we'll check how to do it and find out, fix it. Maybe just explaining it within 30 minutes again, because it's almost like very easy also to explain it. It doesn't require much. It's just 30 minutes can be done with that. So that is the quantitative techniques. Time series is not also not so much popular. I think, you know, I don't know if I'll ever find time to do it. If I find, well and good. If I don't find it, I'll check if there is any other thing I've done on it and maybe share with you for that case. Any question? That question required 14 marks during this period of 2017. It was a question which we needed to use this as a factor of that. Unless at one time I was thinking maybe it required us to use this net cash flow to project, but I realized maybe that's not the case, because it is also how you interpret the English kind of concept. I realized they just wanted us to use the 40% of 4 quarters and find out if they can manage to pay this rebranding. That is the issue, to make a budget and then use it for that. So, any question?
Yes, sir.
Yes.
I don't know. The network has been a problem to some of us.
Yes, please.
And
Sorry.
And two, it's like you have been using like Excel formulas, and when you are coming to revision, sometimes we may not realize where some of the figures were coming from. So I don't know if we like probably on Sunday, if you would spare like 5 minutes and you repeat this question, because it is very key.
Okay, if I get time, I'll try to say if I can repeat on it, because also Sunday there's a lot of things to cover. But what I can say is that I'll also, to assist you, or to assist where I've not put the formulas, before I send Excel, I'll try to make sure I furnish or polish it. Because I notice also me, there's a reason why I was doing that way. I was doing to keep time. I noticed the question would require time. So what I did was to avoid putting formulas everywhere. But I'll put the formulas before I send the question. Yeah? It was a strategy to keep with the time for me to avoid the time factor. Because I noticed I was starting the question and it was around 8:20, and the question seems to be taking almost like some good minutes. If it was me in exam, maybe I would have thought otherwise to do another one and finish with this one, because maybe there's others which could be done within short time. Unless there are no others, then I have to suffer. You have to suffer with this one. So anyway, I'll do that. I'll share the formulas of every part I've done. And then probably if I get time on Sunday, which can also be a big task, I'll try to see if it's possible for me to do it again. Anyway, just as time has gone so much, and I'd wish to cut off this. It's already 9 something. In class, for those who are in Kigali, we'll meet, of course. We have not done linear programming. So we'll meet to do linear programming and shutdown decision. And then I'll jump to variances for the sake of that. Then if time allows me in the afternoon, maybe I'll do this question again if and time series, if time keeps me in check. But for now, I think I can cut this off and say good night.
Okay. Good night.
That's awesome.
Thank you. Good night.
Good night.